this animation? Oh, this is the one. Yes, yes, yes. Yes. Hmm? Yeah. Rama is not there. Has he given presentation? No, I don't see. Okay, fine. Yeah, yeah, yeah. Yeah. Yes, yes. So we'll wait for another minute or so. Yes. This one? Yes. Perfect. Hmm. 20 minutes. 5 minutes. Okay. Good afternoon. Welcome back. Hope you had a good lunch. So, our next session is aerosol climate interaction. I request Professor Chandan Sarangi to chair the session.
Thank you. Welcome back. I think we can wait for 2 minutes because I think people are joining back still. So we have three invited talks in this session, and I would like to invite first Dr. Sachidanand Singh from NPL Delhi, and following that we have Dr. Vijay Kumar Nair from VSSC Trivandrum, and then Dr. Ramakrishna Rami Setti, and we'll start, and one by one I will definitely invite, but first of all, Dr. Sachidanand Singh. Yes.
Okay. So, good afternoon. And let me thank Dr. Kanavade and Dr. Uda for giving this opportunity to speak in this NANO Symposium 2023. So, I will try to loosely follow this outline, starting with the introduction and finally to conclusion. So, as we all know that the atmospheric aerosols are minute particles, solid or liquid, suspended in atmosphere. They change Earth's energy balance, trigger climate change, affect clouds and surface reflectivity, so on and so forth. They can be primary and secondary, natural, anthropogenic, and depending upon various sources, there is a huge contribution of it per year. Although this is old data, but still it's a huge number to contribute in the atmosphere. And the residence time, as you are aware, in the troposphere is around 5 to 7 days. And if you take mean wind speed around 16 to 17 kilometers per hour, so roughly they travel a distance of about 2,000 to 3,000 kilometers in the atmosphere. And that is why they make impact not only from the area of their origin, but also at a very long distance. In the stratosphere, the residence time is something from a few months to a few years, and that is why they affect very much there. Now, the contribution of these can be assessed from the point of view that if we compare it from 1850 levels, then just between 2005 to 2015, in 10 years, the anthropogenic aerosols have increased the scattering and absorption by something around 14 to 30%, and the cloud droplet numbers have increased to something from 5 to 17%. And these obviously will exert the atmospheric forcing, radiative forcing, and they are supposed to be offsetting the radiative forcing by greenhouse gases, something in the range of 20 to 50%. Now again, just for the sake of completion, this describes the whole process, how the aerosols modify the Earth's radiation budget, and they directly scatter and absorb by scattering and absorption, which is the direct process, but indirectly they change the cloud microphysics and also change the droplet in the clouds, which is called the aerosol cloud interaction, and they also affect the reflectivity of the surface. Now, this aerosol cloud interaction, we have already seen in the previous earlier lecture by Dr. Pandit Durai and all, that it is very easy to see the Tomei effect, which is that when we increase the number concentration by CCN, then the droplet radius goes down, and that is the Tomei effect, which is very obvious in the normal water clouds, you can say, or liquid clouds, but it is also there in the in case of ice clouds, where although this phenomena is not very one can be very sure, but they are still there. Anyway, where is the point? Yeah. Like in the ice cloud also, the Tomei effect is there, but it is not to that extent which it is in the water cloud or liquid clouds. So if we see the various IPCC reports, then this is the because in the starting from the second assessment report, the estimation of aerosol radiation interaction and aerosol cloud interaction global picture is given, but up to fourth assessment report, the effective radiative forcing were not being taken into account. But after fourth and fifth ARF, because now there is more focus on understanding the process, so there is an improvement in the uncertainty and also the level of forcing. Now, this is how the aerosol instantaneous radiative forcing and the other forcings are defined. The instantaneous forcing is nothing but here the atmospheric temperatures are fixed everywhere, as you can see from this plot 1. Then there is a stratospheric adjusted radiative forcing, SARF, which allows the stratospheric temperature to adjust. Similarly, the other process is when the atmospheric temperature is adjusted everywhere with the surface temperature remaining fixed, as in this case. But in the, particularly in air 5 and air 6, here the adjustment in the temperature change at the surface is also taken into account, and that is how the forcing is estimated. But for most of the purposes, the aerosol constituents, the atmospheric adjustment is so little that in this case the radiative forcing or particularly the instantaneous radiative forcing is calculated at the top of the atmosphere, and here the tropopause can be substituted. So the in this case there is no need of stratospheric adjustment, and the instantaneous radiative forcing is in that case simply defined as the net change in flux at any level in the atmosphere. That is, we have to only consider the flux change taking down minus up into account. And here is a recent study in which the global distribution of aerosol radiative forcing was estimated. And why I have taken this is because this time frame is around 2001 to 2017, and which matches with our studies. And you can see that the global average atmospheric warming over the land is almost double the global average warming taken into the global perspective. So, which it is from 4 watt to almost 9 watt per meter square. And then there are hot spots like Africa, Southeast Asia, China, and including the Indo-Gangetic Plain. And also the top of the atmosphere and surface, it has a warming trend, linear warming trend, but in the atmosphere there is a slightly cooling trend which has been observed during this period. Now coming to India, where the same time frame, almost 2000 to 2016 that we have studied. Of course, there is a total AOD which is consistently showing an increase on per year or per decadal range. And then the increasing trend you can see is in AOD is mainly because of the spherical particles which are increasing over the time. And also if you see the trends in the particle size, then it is the increase in total AOD is mainly because of the spherical and urban, basically industrial generated pollutants, which are smaller in size, and they are increasing over this time frame. So it is because of these we are having increase in the aerosol concentration. The similar trend is also when we take only the IGP into perspective. So here you can see that the highest increase in AOD is found in the lower IGP region, where of course the industrialization is increasing over the time, and the anthropogenic activities are more. Then there is a decreasing AOD trend in the northwestern region and some of the part of the central south, and which is mainly because the dust storm activities during this period has actually decreased. So that is why there is a decrease in the western region, western part. There is a decreasing trend. And then also you can see that there is a trend in the cloud optical depth, which is also varying from the west to east, and it is changing from minus 0.5 to plus 0.6 in terms of cloud optical depth into the entire region. And obviously this will have effect on the radiation. So the short wave as well as part radiation both are seen to have effect of the order of minus 5 to 5 watt per meter square. These are some individual stations at which, again, the increasing trend is there. Also, this is compared with the aerosol properties from the aeronet stations, which are lying in the IGP. And the interesting thing is that there is a linear increase in the various aerosol parameters like cloud, fine mode fraction, angstrom exponent, then the absorbing aerosol. So you can see that these stations are actually aligned from west to east, and they are increasing here, slight increasing trend. Again, angstrom exponent, absorption aerosol optical depth, and this is the refractive index, which is imaginary part of the refractive index. So all this indicates that there is a systematically increase from west to east IGP in the absorbing aerosols, and their concentration is increasing. But overall, if you see the entire region, the fine mode fraction is still below 0.5 in the overall region for at all the stations, which predominantly shows that there are coarse particles which are dominating in the IGP region. Now, there are various types of aerosols which are available in this IGP, or at least they can be categorized in terms of mostly dust. It can be mostly black carbon, and then the mixed phase of BC and dust. So in the western side, which are, say, Karachi and Jaipur-like stations, mostly dust and mixed BC and dust kind of aerosols dominate. In the eastern region, like Kanpur and others, which are heavily industrialized, there we'll find the mostly black carbon and mixed, again, BC and dust kind of aerosols. So for example, in the Gandhi College, which is at the most eastern part of the region, you will hardly find the dust-dominated aerosols over there. So the absorbing aerosols increase in also the season-wise, pre-monsoon period. These absorbing aerosols are more compared to the other the winter season. If you look at the vertical profile of the aerosols in the IGP region, then if you see, if you study the color ratio and the depolarization ratio, so the color ratio will give you the size of the aerosols, depolarization, again, the shape of the aerosol. So if you study it closely, then in 1 to 4 kilometer range, you can see that the large particles with high color ratio and non-spherical particles with high depolarization ratio overall dominate in the 1 to 4 kilometer region in the IGP. Then if we study the what are the types of various clouds and what is the cloud vertical structure in the endogangetic plane, then over this long period of time, we find all kinds of clouds are found in this region. Almost every kind of clouds, but the high-level clouds, particularly the cirrostratus and deep convective clouds, they dominate in the IGP region. The cloud vertical structure is very much different in the monsoon season compared to the other seasons in the IGP, and they are also different if you compare them from the urban agglomerates and the normal average IGP region. So in the urban areas, the cloud structure is far more different than the other IGP regions. And the average depth of single layer aerosols, single layer clouds over the IGP is actually higher. It is around 2.5 to 5 kilometers. But in the urban areas, it is at lower level, 1.8 to around 2.7 kilometers. So that is how the different cloud types and their vertical structures can be seen in the Indo-Gangetic Plain. This is again about the vertical structure of different clouds in the region. Now, if we see that how these aerosol cloud interaction, what impact it is having in the entire Indo-Gangetic Plain during the same period almost. So here we have studied the aerosol optical depth due to small particles, which is small means less than 0.35 micron, and the large particles, like which are greater than 0.7 microns. So how they are interacting with the clouds. So different cloud parameters were studied against these two types of AODs. So the cloud fraction, then cloud optical thickness and other parameters were studied. So the cloud fraction increases with increasing AOD in general, but then there is negative correlation between aerosol optical depth and cloud optical thickness, and which is against the first indirect principle. Indirect effect that we know as a Tommy effect. So this we call it as an anti-Tommy effect. Also, the cloud effective radius in the liquid phase only we have studied, no ice phase. So here it is negatively correlated with the small size aerosols, which is basically the Tommy effect we are aware of. But there are the processes, there are where we see positive correlation with the aerosol optical depth, particularly with the larger particles, and which is sort of the anti-Tommy effect that can be seen here. If different clouds are studied against the same parameters, same small and large aerosols, and they are not very different, so irrespective of the cloud types, the larger particle aerosol optical depth are negatively correlated with the cloud effective radius in the liquid phase compared to large. So the similar anti-Tommy effect is everywhere reflected. Okay, so this already explained earlier. The elevated aerosol layers in the IGP region, they are affecting they are causing the tropospheric cooling, and also these aerosol-induced tropospheric cooling, it increases with the increase in cloud coverage. And the aerosol cloud interaction further contributes to the lowering of the tropospheric cooling. So it is a kind of cycle which is set in, and again the aerosol-induced lower tropospheric cooling will affect the cloud distribution and cloud dynamics. So it becomes feedback which keeps on generating and changing the cloud parameters. Then coming to the aerosol indirect effect, which was also studied in the IGP region. So here we studied aerosol indirect effect in different cloud thickness with different liquid water phase, liquid water content. And for different liquid water path, you can see that the average aerosol indirect effect over all liquid water path is high for compared to the smaller particles. And the highest positive aerosol indirect effect is observed for the small particles, which you can say these small particles are causing more aerosol indirect effect compared to the large particles. And the aerosol indirect effect is for very thin clouds, that is the low liquid water path, it is negatively correlated with the negatively correlated in case of the thin clouds. Then coming to the aerosol cloud radiation interaction at IGP, we try to find out the cloud forcing. And the cloud radiative forcing for short wave, long wave, and net forcing using this formula, which is the standard one. This is the ongoing work which is going on. And you can see that if you study this during monsoon and summer, in summer you can see this frequency of distribution and the fit, they are at 0 level, so which is indicating that there is almost cancellation of short wave, long wave radiative forcing. But it is not so in case of monsoon, and where it is at minus 10 watt per meter square. Similarly, at surface also the behavior is entirely different in summer and monsoon. In monsoon it is very much skewed towards left, and even in atmosphere there is a change in cloud radiative forcing. So the cloud radiative forcing, the difference between the pre-monsoon and post-monsoon, maybe here you can see the pre-monsoon and post-monsoon differences in the top of the atmosphere, different types of radiative forcing, short wave, long wave, and net radiative forcing is very much different. And so much so that the difference in the long wave radiative forcing here, you can say, it becomes almost negligible. So that is all about the different aspects of cloud radiation and aerosol interaction, which we have seen in the endogangetic plane, and this is the summary of what we have done. I've already spoken almost all of these, so maybe you can have a look on that. So that's all. Thank you. Yeah, these are my students and collaborators, and funding agencies. So
Thank you.
thanks.
Thank you, Dr. Singh. Any questions? Yeah.
Yeah, thank you. Very good lecture. Just I want to curious to know, how do different cloud types, like from low cloud to high cloud, like stratus, altostratus, cirrus, so respond to changes in aerosol loading and composition, and how does the effect of earth radiation budget?
See, the aerosol, when they enter the clouds, and it depends upon the what height. If it is lying above the cloud, if the aerosol layer is lying above the cloud, it will have, say, you can imagine it as a dark surface over a bright surface. So in that case, the effect will be maximum, the reflectivity. But if the aerosol layer is lying below, which is itself a dark surface, and the cloud surface is which is the bright surface, which is above that. So it really depends upon the difference in the bright and dark surface combination. If the surface is almost of the same brightness, then the effect on radiative forcing will be almost negligible. In that case, you won't see any change. So whenever there is a contrast, there will be a change in radiative forcing. So that is how it will.
Any other question? One quick one we can take. Yes.
Sir, like absorbing aerosols, we mostly refer to black carbon. So how about brown carbons, which are also absorbing ones? How to account for that, like radiative forcing?
Yeah, black carbon is maximum absorbing, but there are, say, for example, in endogangetic plane, if we have dust which is also rich in iron and all, they are also absorbing. So, and then the brown carbon and black carbon, the difference is that they act at different wavelengths, they are absorbing. Black carbon absorbs all the radiation which is falling on it. Brown carbon is not so absorbing compared to that. So obviously their effect when they are mixing with the, say, clouds, then the effects will be entirely different in that case. So the forcing will also be different.
Yeah. Again, thank you, Dr. Singh, for this interesting talk. And with this, I would like to also invite our next speaker, Dr. Vijay Kumar Nayak, VSSC. And I believe he will talk more about other absorbing material also in his talk.
Is this one? Vijay.
Yeah, thank you, Chandan, and I will also join with all the invited speakers to thank Vijay for organizing such a nice conference here. So from where Satyendra Singh sir stopped, we will move a little bit north. We will talk about what is the effect of aerosols over the Himalayan region. So here I will be mostly talking about the snow-covered part of the Himalaya, where how aerosols are going to affect the climate, so how, whether it is relevant. So very broadly, I will discuss about that one. So we know that Himalaya is a lot of significance in our regional climate. Probably this has a barrier effect on monsoon, and also it has a thermodynamic feedback on the monsoon, and it provides a lot of fresh water for the billions of people living in the living in the South Asian region. Lot of rivers arise from that one. This is a main freshwater reservoir. So the health of the glaciers over the Himalaya is a major concern. Lot of scientific discussions are happening on that aspect. Whether a micron-sized particle, whether it can contribute something to such a large scale system is a major scientific problem. So we know that Himalaya recently, these are all things to put the things in perspective, what I'm going to talk about. This shows that Himalaya is facing a lot of extreme events, and it's a hot biodiversity point, and it is very vulnerable to the climate change. And recently we have seen a lot of cloud burst and all those things. Whether we can directly attribute this to climate change is a different question, but these are very important as far as the country, India as a country is concerned. So the recent report from compiled by IATM, Sabin's chapter talk about the climate change over the Himalayan region. It clearly shows that the Himalaya has more warming trend than that of the Indian region. So Himalaya is warming much faster. So 1 degree or 2 degree change in the Himalayan region, whether it is going to affect the glaciers over that region is a major concern. So you can see that in any scenario if you take, we are expecting much more warming in the 2100. Other than that, there is one more important thing. When you look at the vertical distribution of the temperature trend over the Himalayan region, what you see that at higher altitude, it warms more. It's called elevation dependent warming, EDW. That's a major concern. So EDW has a lot of importance over Himalayan region, especially because most of our glaciers are mountain glaciers. So temperature, if it is increasing at a faster rate over the high altitude Himalayas, it can kill a lot of glacier or snow over that region. So all these things make the study over the Himalayan region and its fast melting very relevant. So we will just look at what are the sources and the sinks of aerosols over the Himalaya. We know that there is a lot of hot spots sitting near to the Himalayan region. Lot of anthropogenic aerosols are emitted from the Indo-Gangetic Plain and South Asia. They goes up to the Himalayan region, and there is a dust transport which is coming from the Thar Desert or Middle East or in the much western part of that one. These particles can get transported here. With the dry and wet deposition, this particle can deposit on the snow surface. So snow is very white, no doubt about that one. So when we look at the snow which is impacted with the aerosol, it looks something like this way. And in the extreme cases, you can see these are the pictures over the Arctic region. This forcing, the aerosol deposition over the snow surface is considered as one of the major forcing mechanism over the Arctic region, but we don't know much about over the Indian Himalayan region. So this is the one. So if you look at the spectral albedo, interestingly, the albedo reduction happens mostly in the visible region. So we know that maximum radiation is coming in this region, so it should have a large radiative forcing. To address this program, we started somewhere in 2011 or 2010, we started this program. So initially it was field expedition to Himalayan glaciers to understand that how much is the BC over that region. So we cannot simply start the program. So we went to the Himalayan glaciers, lot of expedition to the glaciers. We directly went there and measured how much is the black carbon over that region. Another problem is whether the black carbon from the South Asian region, the Indo-Gangetic Plain goes to the Himalaya. So what we did is we took aircraft and we measured the vertical distribution over the IGP region and found that during pre-monsoon time it can go very up in the atmosphere. So these particles can reach the Himalayan region. So after that we started regional climate modeling. So I will be more focusing on this aspect, just touching upon the some of the observations over the Himalayan region. So you can see that these are the observations made from different glaciers. Expedition to glaciers, some of the people may be aware, especially Chandan is aware, it's very, very tough job. So you have to travel at least, you have to do trekking for at least 2-3 days to reach the glacier. Then do some measurements there, 2 or 3 days, then come back. It's a very hectic job. So we did little bit of that one. Don't go for these high values, just to look at the mean values. We are talking about the climate perspective, so just look at the mean value. It will be somewhere around 200 nanograms of particle in a meter cube of air. This is a pretty big number. If you compare with the Arctic or Antarctic values, earlier it was mentioned, these values are very, very high because we are close to the source regions. And if you see the vertical distribution, it is decreasing with altitude, expected, because the aerosols are mostly at the valley region. So with altitude it is decreasing. And it is peaking during the pre-monsoon time because of the large scale convection. Aerosols are going up in the atmosphere, and if you see the vertical profile, calypso profile, if you see, you can see that there is a lot of aerosols which is lying in the mid-troposphere or upper tropospheric region. Then we did profiling in the snowpack itself. This is a snowpack profiles of aerosols. You can find that even at 1 meter below the surface, you will find a lot of black carbon aerosol. It is getting accumulated. It is compared to the atmosphere. In the snow, the aerosol depositing on the snow is, with the time, it is accumulating. So what we did is, sorry for this poor quality in the figure. So what we did is we used a regional climate model. It is an Italian model. It has an online aerosol scheme. It has a chemistry model. It has an online aerosol scheme that is connected to a land surface scheme. In the land surface scheme, we have a provision for the deposition of aerosol that is going to affect the albedo of the snow, and it is connected to the radiation. So we call it as a SAE. SAE means snow albedo effect. We can call it as a snow darkening also. Snow is getting darkened. So we call it as a snow albedo effect. And same way you can have a direct effect of aerosol, DRE. Sachandra Singh was talking about DRE quite a lot now. So this is called a DRE. DRE means direct effect. These aerosols are in the atmosphere. It is a DRE. When it is at the snow, it is called SAE. So these are the two effects we anticipate. So what I do is I won't spend much time on my result side. This is the one slide where I compile all the results together. So I will spend some time on this one. First, aerosols are getting deposited on the snow surface. Then it changes the albedo. It decreases the albedo significantly in the visible region. Because of that, it leads to some warming. Warming is positive, meaning that it warms the snowpack. When it warms the snowpack, temperature increases. When temperature increases, it reduces the snowpack. We know that the temperature and the snow surface, the snow cover fraction, SCF is snow cover fraction, they are directly linked, because if it increases the temperature, SCF decreases. If SCF decreases, it increases the temperature. It's a positive feedback mechanism. So it goes feedback to the system, so it enhances the initial signal. Because of the increase in temperature at a high altitude, we know that it can change our monsoon pattern. It can change the not monsoon pattern. It can change the rainfall pattern over this region. So same way, this excess melting will change the runoff. So we will have more runoff over the Himalayan region. So the rainfall is also connected to the runoff. So this feedback to the albedo, because when you have more rainfall, it is coming as a snow over that region. So your albedo will increase. So it gives some sort of a negative response to that one. So this aerosol darkening, surface darkening will change the direct effect of aerosol. The snow darkening due to aerosol deposition has implications on the atmospheric, the way atmospheric aerosols interact with the radiation. So that's a very tricky part. Since snow is melted very fast because of the aerosol, it exposes the land. So that leads to the dust emission. It acts as a new dust source over the Himalayan region. Since it is a new dust is coming into the atmosphere, it has implications on the DRF. And this excess dust can again deposit on the system, and this feedback will continue. This is another forcing feedback mechanism. And finally, this DRF is cooling the surface, and the snow albedo effect is warming the surface. It can compensate the DRE effect. So all these complex processes we can address using a regional climate model only. So there is a lot of positive and negative feedback mechanisms are coming. So what I will do is I will go by one. So finally, I will spend one slide on the elevation dependent warming also. So if you look at the deposition of aerosols over this region, this shows the emission minus deposition. We can see that over the whole Indian region, emission dominates. The deposition dominates over the Himalayan region. Over ocean also, we don't have sources here. So deposition is dominant feature over all these regions. If you look at the concentration of black carbon and dust over the Himalayan region, they are pretty big number. One is in microgram per kilogram, another is in milligram per kilogram. So since BC is very, very effective than the dust, their forcing will be comparable. That even you can see that in the Chandan's paper also. And if you look at the albedo change, there is a significant albedo reduction happening because of the aerosol induced deposition. So albedo change leads to a large amount of warming. If you look at the forcing values, they are 20, 30 watts per meter square. These are pretty big numbers compared to the amount of aerosol available over this region. If you calculate the DRE forcing, it will come around to minus 10 watts per meter square at the surface. So the deposition of aerosols is almost 2 to 3 times larger than what aerosols is there in the atmosphere. So it leads to a temperature change. This is the one we are more interested. The temperature change is of the order of 1 Kelvin to 2 Kelvin. So it's a very, very big number. Aerosol deposition leads to 2 Kelvin warming over the Himalayan region. It decreases the snow cover fraction pretty over this region, and not only the fraction, the last box, it shows the number of days in which snow is available. In 365 days, how many days each pixel is snow covered? You can see that almost 20 to 30 days are missing because of the aerosol deposition over the Himalayan region. One application, but we can look at all the climate models. If you take, there is a cold bias over this region. Any IPCC model or any model you take, you will always find a bias over the Himalayan region, especially the Western Himalayas. That bias can be reduced by including aerosols into the simulation. So when I do with and without aerosol, you can see that the bias significantly reduces over the Himalayan region because of the aerosol deposition. So I will just spend I will just discuss about the hydrological effect, aerosols on the rainfall and runoff. Yeah, aerosol leads to warming over the Himalayan region. This is topography shown. You can see that there is a significant warming over this region, but this is highly localized. So it doesn't have much implication, but you can see there is an enhancement along the Himalayan foothills, and other regions don't vary much. You can see there is an enhanced precipitation over the Himalayan region during March, April, May. These enhanced simulation that can add to the snow melt also, river runoff also. You can see that same way when aerosol warms the Himalayan region, snow melt increases significantly, and also the snow cycle moves forward. So meaning that suppose if snow melts during July-August period because in the control run or without aerosol run, with aerosol, it goes 30 days back, meaning June 1st itself, the snow melt mostly over the Himalayan foothill regions. So the snow cycle is getting affected, as well as the amount of snow is getting melted is also getting affected because of this aerosols deposition. And this is a work we published in WRR, Water Resource Research. And what we have showed here is over the Western Himalayas, because of aerosol, there is 2 things are happening. One is the total amount of snow melt is increasing in the presence of aerosol, and also, as I mentioned earlier, the snow cycle shift towards more pre-monsoon side. So that indicates that the glacier, which is the glacier without snow protection, is exposed to the solar radiation, and it will change the energetics over that region. You can imagine like one region is covered with the snow. Once you remove that one, it exposed to the solar radiation, and your all surface energy balance changes because of this one. And if you look at the extreme snow melt occurrences, that is 99 percentile, the number of cases after the 99 percentile, if you see control run, it shows almost 1,500 events for whole pixel during the entire simulation. I just put the number here. And it doubles. The take-home message is over the Western Himalayas, the extreme snowfall events increases almost 2 times because of the aerosol events. So extreme snow melt is increasing because of this one. So this we have seen also over the, this is valid for the Indus Basin, which goes from Western Himalaya through Pakistan to Arabian Sea. So here we have the implication. So last one, how these aerosols affect the DRF. How much time I have? 4 minutes. Okay. So how aerosols affect the DRE. So this is very different. So here what I'm going to talk here is aerosols are deposited on the surface. This surface deposition, how is going to affect the aerosols in the atmosphere. So that's what I'm going to discuss, and we all know that the way the atmospheric aerosols interact with the radiation is mostly dependent by your surface albedo. Albedo is a big animal as far as the direct radiative forcing is concerned. So if aerosol going to decrease the snow albedo, it will change the direct radiative effect of aerosols. And you can see that this is the equation which connects the surface albedo and radiative forcing, and you can see that when the surface albedo is very low. So simply what I mean to say here is, suppose if you do a radiative transfer calculation over above snow region, a small number of particles, maybe a few nanograms of BC in the atmosphere will make your top of the atmosphere warming. So over a snow surface, you don't need much absorbing particles to get warming over the top of the atmosphere. Whereas over the ocean, if you pump tons of black carbon over that region, you will not be able to make top of the atmosphere warming over the ocean, because ocean albedo is much, much lower than the black carbon albedo. So there is almost impossible to make the top of the atmosphere warming over ocean, but it is pretty easy to change the sign of the radiative forcing over the snow surface. Change the sign of the radiative forcing over snow surface is very easy. So that's what we investigated. What we found is without aerosol forcing, you can see that this is of the western Himalayas. The top of the forcing is positive, meaning it is warming over the Himalayan region. It is always positive over this region. When I included the snow darkening effect, this red one, you can see that in the June-July period, it changes. The positive forcing changes to negative, meaning that warming changed to cooling over the Himalayan region just because of the snow darkening effect alone. So, as I mentioned earlier, when we have snow albedo effect, that leads to more warming, then snow melt happens. It exposes the non-vegetated land. The entire snow is gone away. So, Himalaya, those who are visited Himalaya, we know that it's a very loosey sand. So, it acts like a dust source, and this increased dust source again deposit on the snow. This goes as a positive feedback mechanism. So, that we investigated, and we found that this excess dust source is mostly sitting over this region. So if aerosols remove the snow cover over the Himalayan region, it will add as an additional dust source over this region. So an additional dust is coming into the atmosphere, and this additional dust is again affecting the direct radiative forcing. So that is somewhere around -4 watts per meter square. Out of 30 I was mentioning earlier, -4 watts per meter square is compensated by the snow albedo effects of aerosol itself. So this is already published in JGR. You can just refer to that one. And finally, this is one work which we are currently doing. So it is elevation dependent warming. I will show one figure. In that one, what you can see is, as I mentioned earlier, when BC is decreasing with the altitude, I mentioned that there is nothing interesting. It is expected because sources are at the surface. When you go up in the atmosphere, your BC will decrease. There is nothing wrong in that one. But if you look at the total radiative forcing, the SAE due to total aerosol, you can see that at the higher altitude, the aerosol forcing is increasing. When your concentration is decreasing with altitude, how can your forcing increases with altitude? This is mostly because of the snow albedo, snow microphysics, because radiative forcing due to aerosol is not only depend upon the loading alone, it depends upon the snow depth, snow density, snow grain size and all. So that is why we get this kind of a nice pattern. Your warming increases with altitude. The watts per meter square means it's nothing but a temperature, it's Kelvin. So you can see that when you increase when you go up in the atmosphere, when you go up in the Himalayan region, your forcing increases with the altitude. And interestingly, if you see the direct radiative effect, the aerosols which is present in the atmosphere, that shows that it gives almost a -25 watts per cooling at a 2 kilometer altitude. 2 kilometer, I think, Kullu or Dehradun, that altitude comes around this one. And from there, if you go up, mean around 5.5 kilometer, the cooling decreases. Meaning both are same. Here it is warming increases, here it is cooling decreases. Whether it is direct effect or SAE, both have same effect on the temperature. So finally we calculated how it is going to affect the temperature over this region. We found that a pretty big number. So I am not emphasizing more on that number maybe we have to check. So I thank all of you, and these are the publications. You can just have some look. And this was my PhD student. She did all this work and she completed. This is my senior and division head. He was supposed to present this talk here. And I also thank Sushant. He is from ICTP, did PhD with the Saknik Day, and he's now in Stockholm. And these are the people contributed. Thank you very much.
Thank you, Dr. Nair.
Hey Vijay, nice talk.
Yeah, thank you.
I have a couple of questions.
Yeah.
So first, simple questions. So you showed that you have measured dust and black carbon over snow, right?
Black carbon we measured using atolometer.
Black carbon in air and in snow also.
Yes.
So how did you measure that?
Black carbon using atolometer.
Okay.
Snow using transition meter.
Okay. How many sites you have covered when you were covering Himalaya?
Initially we went to Sadoband, then Kolhoi, then total glaciers will be somewhere around 30 now.
30.
To 40, yeah.
30 to 40.
Yeah.
Okay. So one thing what you were talking about the dust, that if snow melts and dust is going back.
Yeah.
So don't you expect that once dust has fallen on snow, then they will come together, they will agglomerate and become bigger particles. So it will not go in the same way as when it is coming from, say, it is coming from some desert or something. That kind of dust, and what if the snow is gone, this dust is coming back. So it will be quite different.
No. Actually, dust comes, it gets deposited on that one. When snow melt starts, the melted water will carry some of the dust along with that one. Some will remain there. Then once this entire snow is removed, then barren land is exposed. So from there, depending upon the wind speed, again emission starts coming.
What I was saying, this whatever is coming again from the snow, after snow melt, and whatever was coming initially, that virgin dust, whatever was coming earlier, I don't expect them to be similar.
One is coming from West Asian region, deposited, melted away by the snow. This is from the central Tibetan region. It's a freshly, from that region it is emitting. It's a new dust is emitting. Other one is gone with the water. We have a runoff happening because of the snow melt. With the melted water, it has gone. So
You are saying there is a loose dust?
Yeah, loose dust.
Which get exposed by the
high wind speed, it will start emitting from that point.
And one last question is, you were showing the vertical profile of black carbon from different sides. And then you showed Henley was the lowest, and then you go further up, it was increasing. Why? SU, yeah. It was higher than the Henley.
Value. So when we go to the very low concentration, systems will have
That looks significant because your scale was in microgram per meter cube, and they were in nanogram. You can see that in microgram scale, that means...
Yeah, I agree. Because Western Himalayas, the Hanle was in Western Himalaya, this is more like a free region. But when NCOP, that is comes in a valley region, so there will be confinement coming. So always that number is higher than our value, so it is high in the altitudes. It because of the how our site is located. Hanle is on the top of one mountain. There is no confinement. It's a clean air. It is in. It is at 4.5 kilometers. NCOP is in a valley domain, so there is some confinement is happening in the valley, so that could be one reason. I am not very sure. I can look into it.
I have another explanation for the same question. Generally, like it's also distance from ITP. So Hanle is very far. It has to cross through 3 ranges, and NPR is just after the Great Indian Range, Himalayan Range. So in my experiments also I saw the farther we go, it's the first range gets maximum. The first range gets maximum deposition, and then till Hanle it doesn't.
Yeah, thank you. Very nice lecture. Just I'm curious to know, when we are talking about our Himalaya aerosol deposition and composition, whether we consider the ITCZ, Intertropical Convergence Zone. So we know in summer, ITCZ move towards the foothills of Himalaya. During winter, it's come down south of the our Indian region. So how does it affect, whether you are considering this ITCZ impact on deposition and composition of aerosols or Himalaya? Just I want to curious to know.
No, the whole presentation I focused only on pre-monsoon time because that time is the transition time. So ITCZ is still in our ocean only. So that may not contribute to this one. Pre-monsoon, March, April, May only I was talking about the full discussion.
Okay.
I have a small question. So you also showed snowfall increment because of SAE.
In model we don't have a snowfall directly, but since the surface temperature is still below 0, we presume that it would be.
And it's during monsoon or pre-monsoon? Or winter season?
Time we don't look at that one because that time dynamics is different and it's a large scale phenomena, large scale dominated one, and the concentration decreases over the Indian region. So we focus mostly on the pre-monsoon way because pre-monsoon time we have a large amount of solar radiation and aerosol concentration is high. Naturally it is melting, so it acts like a catalyst. This aerosol acts like a catalyst to the snow melting, so it enhances the melting. That's all.
Thank you very much.
So like you showed that like transport of primary emissions to if Himalayas, it will impact negatively like positively towards radiative forcing. So what about like new particle formations over those regions? Because it will have negative impact and it may compensate whatever positive impact you are showing, through radiative force, modeling studies?
Yeah, Himalaya is known for new particle formation, and people call this as the main source. There is a lot of new particle events are already reported, as Chauvin is also reported. A lot of new particle formation is happening. That new particles are adding to the total aerosols, scattering aerosols available over this region, and this is the radiative forcing due to the total aerosols available in the atmosphere. DRE, what I mean. So forcing is somewhere around 0.2 or 0.1. This is about the primary aerosols, black carbon and dust deposited onto the surface. That's a big number. So this sulfate, when it is getting deposited to the snow surface, nothing happens because sulfate has 0.9 albedo or 0.96 albedo. Snow is also having 0.96 albedo, no change. But organics can have still a significant effect. I have not included organics in this simulation. So organics could be a potential contributor.
I think we can take this discussion.
MBF is not included in the model. These are climate models. We go with the very minimum aerosol content or aerosol chemistry or atmospheric chemistry. Otherwise, it kill our all time. So,
very sorry to be the spoil sport, but I have to keep time also. So, thank you very much, Dr. Nair. And with this, I am also happy to invite our next speaker, Dr. Ramkrishna Ramisetti from TSI Instruments India, Bangalore. He will talk about nanoparticle measurement techniques.
Hello all, very good afternoon. First of all, thanks a lot to Vijay to inviting me here and being part of this wonderful session. Actually, this topic is very close to my heart. When I was doing my postdoc and PhD, I was working on this new particle formation and nanoparticle studies from both physical and chemical characterization. But in last 4.5 years, I have been with the TSI. But time to time, I am engaging with some of the professors and scientists who are working in this field. So I will brief you on some of the measurement techniques which are useful for the nanoparticles, or which we call it as ultrafine particles, for both atmospheric and air quality studies. So outline of my talk is I will just brief you about TSI instruments and atmospheric aerosols and tools for the aerosol characterization, and TSI solution for the SENS standard, which is recently came up in the Europe. And also I'll show you some of the global trends in the aerosol studies. So TSI is a US-based company. It is into particle instrumentation or aerosol instrumentation since last 60 years. We have been developing continuously the new equipment collaboration with the University of Minnesota and other institutions. And majorly we have been dealing with, in this particular division, we have been dealing with 3 major applications. One is atmospheric aerosol studies, and the other one is filtration applications, and the other one is engine exhaust emissions. In all these applications, we have been providing solutions from 1 nanometer up to 20 microns. So there is no single instrument that can measure from entire aerosol range from 1 nanometer to few millimeters. But we have equipment which are dedicated for the different objective of the scientists or professors depending on their application. So I don't want to tell more about this graph, but I can brief you on this. The aerosols are very important to which are the origin and evolution of the aerosols is very interesting or important to understand the effect on the scattering and absorption of the solar radiation and the cloud condensation nuclei, and other important thing is the health effects on the human health effects. Okay, for all these 3, we have been studying these aerosols, and most importantly, when you will look at in recent days and recent studies, they are showing that these nanoparticles, especially the ultrafine particles, can go very deep into lungs, and they can penetrate with the blood cells, and they can go anywhere in the body. Okay, So in this topic, I'm only concentrating, in this presentation, I'm only concentrating on the measurement techniques for the ultrafine particles. I'm not going into PM 2.5, PM 10, because many of the people are already using a lot of different equipment for the low-cost sensors to high-end equipment. So this picture is from the very good book for the atmospheric aerosol measurements, principles and techniques by the David Louis and Pui. So in this picture, we have three basic parameters, that is mass, number and size of the aerosols. For each parameter, we have a direct sensing method and indirect sensing method, and also for different sizes, and also by different light scattering methods, and also different resolutions. We have various different methods to measure the particles from the in the atmosphere or wherever we have the sources. Okay. For example, if you look at the direct sources, quartz crystal microbalance or vibrating mass sensors or beta attenuation method, and the indirect methods like light scattering methods, what we have with the nowadays we have lot of low-cost sensors. And also for the number concentrations, we have for ultrafine particles, we have condensation particle counters or electrometer methods. And similarly for the bigger particles, we have optical methods, light scattering methods. And also the aerodynamic diameter, which is one of the best way to measure the larger particle size distributions. And similarly for the different high resolutions, for example, when you look at the size distribution of the particles, they can be now from 1 nanometer to few micron particles. So it is always good to have more high resolution data. So there are equipment like SMPS or LP, there are instruments which can measure size aggregated aerosols. And also there are other type of equipment for the larger particles. So I just put few slides for the ultrafine particle measurements of mass, number and size distributions. I'm not going into detail about this chemistry. So for real-time number measurements of the ultrafine particles, we have an instrument called condensation particle counters, which we in short form CPCs, and electrometer techniques, and also light scattering methods. The disadvantage of the light scattering method is because of the we cannot measure very easily the nanoparticles with the light scattering methods, because the light scattering scattering intensity will be very less, and photometer cannot detect the nanoparticles. So we use condensation particle counters or electrometer techniques, and also some people use, if concentration is very less, some people use filter paper methods or microscopic method to count the particles. So this is the condensation particle counter. Here you can see the picture of the condensation particle counter. And here we have three major parts: saturator, condenser and optics. Here we have an inlet, and the particles will be, the nanoparticles will be pulled into the instrument, and those particles will be, here we have a liquid, that is, we call it as a saturated liquid, or either we use butanol or water. That butanol vapor will be condensed on the particle, so that the particle will grow further, and which can be easily detected by the optics. That's why we call it as a condensation particle counter. So this technique is very well recognized and gold standard method for the nanoparticle counting. Okay, and here I mentioned few things already. So there are different CPCs which can measure from 1 nanometer up to 1 micron or 2 microns. So this is based on the single particle counting, and it measures in real time. Within few milliseconds, the instrument can detect the effect of the for example, if there is a engine exhaust emissions, you can immediately see the effect of the engine emissions. And there are different type of equipment, CPCs, which can measure from low concentration to high concentrations. Even engine exhaust concentrations also it can measure. And even it can measure a single particle. If there is only one particle, it can measure easily. So there is another method which is used to measure the particle counting. This is electrometer method. It's just with the Faraday cup, it measures the charge on the particle and basically a current. So this is another technique, but it is a very high sensitive instrument. Mostly this instrument is used to calibrate the CPCs. Very few people used to measure the particle counting from the ambient. And the other physical parameter is particle size. We call it as a particle size distribution. Many people have stressed about the importance of the particle size distribution in the new particle formation studies. And we have real-time methods like electrical mobility scanning methods or ultra-fast electrical electrometer methods or some of the optical methods and QCM impactors. I'll brief you on this. So this is first method is scanning mobility particle sizer, which can measure from 1 nanometer to 1 micron with the different DMAs. And the other method is this is a fast mobility particle sizer. This is with the electrometer method. This is scanning mobility particle sizer is with the combination of DMA and CPC. And in this, here as mentioned as scanning, it takes 1 minute to 5 minutes to scan from 1 nanometer to 1 micron. So it's a slow process, whereas this method is very fast. Even you can measure 0.1 second data with high accuracy. So this method is used to do the measurements from the combustion systems like engine emissions or from ship emissions. People have been using for such a kind of applications. And this is the scanning mobility particle sizer. It is a combination of two parts. The first part is called as a classifier with a differential mobility analyzer, and second part is CPC, condensation particle counter. So now first of all, when aerosol pulls inside the instrument, it goes to the neutralizer, which gives a uniform charge distribution to the particles, and only one charge particle will come at a time. When we apply to the when we apply electrical field to the rod, central rod, and only one size particle comes out, and that particle number will be counted by the CPC. So in one instance, that means one spectrum will give both size distribution and number concentration of the total in the environment. So if the spectrum looks like this, size versus number. And so you see the importance of the scanning mobility particles or nanoparticle sizing. This is one of the nice pictures. When you measure the mass of the particles, you cannot see the effect of the small changes. When you measure either number or size, you can see the effect of the. This is actually when we started the engine. You can see the effect of the diesel exhaust from the tailpipe. So you can nicely see the changes in the total number of particles, whereas you cannot see that in the mass because the mass of the particles is very, very less, and you cannot easily measure that mass. And this is what I mentioned, the fast particle sizing. And the last part of the physical parameter is mass. So as I mentioned before, this is the size or particle counts versus size, and this is mass versus size. You see here the total number of particles will be very high in this first portion below 100 nanometers, whereas those mass contribution is very, very negligible. So measuring mass of the nanoparticles is very, very difficult. So for this we have an instrument called quartz crystal microbalance with Maudy impactors. Maudy impactors are the cascade impactors. We combined two equipment like quartz crystal microbalance and Maudy. So that is a fusion of two equipment which takes care of the relative humidity of the particles and also temperature. The first portion is the conditioning of the aerosols, and then it goes to the cascade impactors. The quartz crystal, when the particles are fallen onto the quartz crystal, the change in the frequency of the natural frequency of the quartz crystal is proportional to the mass of the particles. So in that way, we measure directly the mass of the particles. So this is a direct mass measurement method. There is no assumptions here, and it is free from the artifacts from the relative humidity and temperature. So it can measure even 45 nanometers from 50 nanograms up to 2.5 microns in 6 different size channels. And also the cleaning of quartz crystal microbalance is very easy. You can complete that within a few minutes. And that particular sample can be used for the chemical analysis. And there is a offline method, which is a cascade impactors, which can measure from 10 nanometer up to 10 micron. This is a rotating disc MODI impactor. People use it for the, there are different type of MODI impactors based on the number of size channels and also the accuracy. So you can go for different sizes. Starts from 10 nanometer up to 10 microns or 18 microns. And in recent days, in last 2 or 3 years, there are changes in the aerosol studies. I have been observing personally on this particular sense standard. People have been talking about sense standard and Actris network, which is one of the biggest networks in Europe. And Dr. Andy also mentioned about Actris network, which is nicely formulated all the methods for the particle measurements from 10 nanometer to, from 1 nanometer to 1 nanometer to up to several microns. So for each, they have clearly mentioned how to sample, how to measure, and how to deal with the data. All these they have clearly formulated. This link is very nice to read. If you have time, please go through that. And they have mentioned for how, which kind of instrument you have to use for the sampling and conditioning and for counting and sizing. And TSI is providing a complete solution for this sense standard, including a sampling system to the counting and sizing. So if you are interested, please contact me. And the other equipment is aerodynamic particle sizer. In Actris standard, for the larger particles, people always use optical particle counters. In optical particle counting, you have a lot of assumptions. You assume the particle shape as a spherical. You assume density as a 1. So with those assumptions, in the ambient, if you measure in the ambient, that the measurements will not be accurate. So this aerodynamic particle sizer will give you more accurate data because we have 2 lasers here. The distance between 2 lasers is known, and when we measure the particle time of flight, that means the time taken from one laser to other laser, that is independent of the density of the particles and shape factor of the particle. That is, we call it as the aerodynamic path of the particles. So we measure aerodynamic diameter with this equipment, and this instrument can measure from 0.5 microns to 20 microns. In Actris standard, there are 2 instruments from the 10 nanometer to 10 microns. One is scanning mobility particle sizer for the smaller particles, and for bigger particles, the technique is aerodynamic method, not the optical light scattering method. Okay, and this is the combination. And we have also some nanoparticle generation techniques, generation instruments for the smaller particles, a simple aerosol generator, which is widely used for in the laboratories. And we have also other equipment from 10 nanometer up to 200 microns. And these are some global trends which I have been observing. One I have talked already. This is aerosol Actris network. And in Europe, there is one more network which is called as a Eurochamp. They call it as for chamber studies, they have a nice network. Yeah. And the mobile monitoring of the aerosols and sensor-based networks and periodical testing inspection of the nanoparticles. These are some global trends. And one of the interesting things is, I can tell you here, China has started these superstations in 2013. They have built hundreds of superstations with all these ultrafine particle networks. We do not have such a kind of network in India. So probably we can learn and we can do something for the nanoparticle studies as well, in addition to the PM2.5 and PM10. Okay. So these are some of the instruments which we have. If you have any questions, I will be happy to answer.
Thank you much. Thank you very much, Dr. Ram Sethi. Any questions?
So, if you have any doubts or questions, or if you need any information regarding our instruments, please contact me. This is my email ID.
Yeah, miss. I wanted to ask how to make instruments cheaper.
Yeah, it's good thing actually, but yeah, what I observe is some people have been trying, but for trying also, for example, if you make any new instrument, to calibrate that, you need a good equipment. For that also, we do not have sometimes funding. There are few people who are asking me such things, but yeah, it should come from the universities or research institutions.
Yes, I believe that.
I know that these instruments are not expensive when you just count the part by part price, but when the companies always have their own formula for costs, right?
Yes.
From R&D days, from this beginning of the R&D to the production, they have different formulas. But frankly speaking, as per my knowledge, I should not talk on this when it is in the
No, miss,
YouTube.
I agree your point. Like
Yeah.
collaboration has to come up
Yes, yes.
between academia
And personally, I am helping a lot of my customers whenever they want something. I am giving my instruments for free of cost for several months. I have been doing since last 4.5 years. And whenever there is equipment lying in my lab, I am giving it free of cost for certain time.
That's absolutely fantastic. Thank you very much, Dr. Ramakrishna. Thank you for this. And I hand it over to.
Thank you.
Okay, thank you, Chandan. We'll have a tea break. We'll come back by 3:30. It's 10-minute tea break if it is okay. We have another session to go. Yeah.
इसी से चला लें, इसमें वीडियो है, वो लिंक नहीं हो पाता है, लिंक नहीं है.
Can I go to the next day's thing? Yesterday. Where is that yesterday decision? So what sir, I have, where is that my thing? Two are there. I want to delete this one. Where is the delete?
ना वीडियो चलाएंगे शुरू में, आपको मैं दिखा देता हूँ, ऐसा ना हो कि वो ना चले. ये एयर पोल्यूशन एक्सपोजर वाला है.
PDF I will keep here.
Okay, sir.
We will delete here.
I will delete, no problem.
Where is that?
Yeah.
Yes. Yes. PDF is there.
Okay.
Okay. Is it PDF only? No?
Yes, sir, it's PDF. Yes, yes. ये एयर पोल्यूशन. हाँ, लेकिन इसमें वीडियो है कुछ, वो यहीं से चलेंगे. इसको यहीं से चला देते हैं और फिर ले लेते हैं. No, no problem. I think you want to play another video of GSA or something else. Yeah, ये इसी में चलेंगे. Oh, no problem. I will copy the 3 things. You want these 2 also? Yeah, but ensure means no issue, right? Yeah, no problem. And I will just copy and then keep it here in this folder. And I can delete later. Hey, if you want, you can delete it later. Because if it is in the desktop in this system, then it will. Can you just try if the video working? They are the first. No. Directly from there. Cut it off. Yeah. This is the one copy. No, PPT. This will play directly from. No. Play the PPT. And now go to the second slide in the larger mode. And if I do 2 click, will they move? नहीं वीडियो नहीं चला. No, you want to play the video. They will play here directly, simultaneously. This will play actually. तो क्या इन पर जाकर क्लिक करना पड़ता है? ऐसा लग रहा है? Oh yeah. This is CQMS, this is continuous air quality monitoring. Yeah, directly they are playing. No. Quality monitoring. I have to come and click here. No problem, sir. Anyway, mouse will be here. चलिए, try. ये तो अभी आ जाते हैं चाय पीकर फिर. Okay, sir. Thank you. Hopefully no PPT. Oh, तेरा pen drive. I will remove it. Thank you. इधर रख दें दिखाने के लिए लगा दीजिए अभी टाइम लग रहा है ये 2 मिनट थोड़ा
working.
Okay. Welcome audience in this last technical session of the 2 days symposium.
And this last technical session will have a new dimension. What was the kind of thought behind this NANO 2023? It has social implications basically, and we shouldn't forget air quality and health interaction. And in this session where air quality and health interaction we wanted to understand, since yesterday we talked about the process level starting from 1 nanometer, and now we are gradually increasing through the transformation, understanding different pathways, and now at the final stage where we need to understand the receptor also. In the previous session, we understood about the climate, and now the turn is of health issues. So we have three very nice talks in this session. Professor Ravindra Khewal from Chandigarh, Professor Sagnik Dey from Delhi, and Professor Santu Ghosh from Bangalore. So without delay, I invite Professor Ravindra for the first talk of the session.
Thank you, Dr. Gupta. Am I audible? Yes. Is it working? Yes, yes. Yeah. So I just wanted to ensure that you all are awake. The coffee and tea were really nice. Hope you will not mind if I stand here and discuss with you so that I can check who is sleeping and who is listening me, like I can check on the back. So we breathe 22,000 times a day. Inhale 16 kilograms of air. 16. And our lungs are filtering out. I wrote a review actually in 2001. It was about toxicity. So some were saying, oh, it's the size, it's the number, it's the physical property, Ferrine theory, Osborne theory, those were talking about, no, it's the chemical toxicity. Someone saying, no, it's the physical shape. It's not spherical as we think about. So all these things really bring focus on the health. That how our body, when we all are exposed, is not affecting equally to all. So before that, why I am here is that I will show you, because we have a site in Chandigarh, and we invite you for collaboration. So I'm running this through site which is Chandigarh.
Air quality monitoring site, and we are seeing the PM2.5 monitor, and this is how whether the whole system is sensor for setting up.
So you can see we have collaborators from Japan, they are working, and these sites are for UX. They are not for
see here, and just most
for me, actually,
purple layer taking you back.
that's
This
why
is
I
much
came here to
monitoring side. We are going to our other sensor out there. So this is the
so these are the sites, and
site.
you can see they
For rural,
at near the rural side also we have a
other emissions basically we are monitoring.
So how clean is the environment?
It's based in
From
Kerala.
rural to urban. The problem is I came from Punjab, and now we are problematic. Why? Because we are producing rice, wheat. We are the food bowl of the country, but we are blamed for the pollution now. In 1970, when there was scarcity of the food, we became the part of Green Revolution. And now we are part of the pollution. But you know, in the Ukraine war, who could feed? It was only this region which could feed, the most productive region. And this is why we need to think about before blaming. And this is the situation, how it looked like. Then we try to understand the emissions, look at not only now in 2050, and these probably could match your interest, PM2.5, means how they will increase, and how these you can say, lightweight volatile organic compound also increase. So your chemistry, your physics, you can work it out looking at our work. And you can improvise, means how these will react in near future. Again, we also looked at how the emissions are there, from which district, and if they are emitting, means why there is more burden there. Again, you can see those districts in Punjab area basically, or in means which are close to the Pakistani area. So why these districts are burning more? Which rice variety they are using? Is it basmati, which we prefer, or it is other? So what mechanization has changed? These are the issues which are leading to these kind of emissions, and these emissions are available for your analysis, or if you want to use them, so we are open for this. Not only this, basically, you were talking about, because we link from satellite data to the ground-based monitoring also, why you see certain pollutants which are coming from the belt of, you can say, towards the Pakistani Himalaya side. And then we have this sink side. So what is contributing and how it is impacting, including the long-range transport we presented there. And then we also looked at the rural area side. How the pollution is varying there. Is it the black carbon which is dominating or other pollutants which are dominating? And here you can see that through the tracer analysis, we also try to understand how much is the crop residue burning contributing to that total emission. The problem is, when we talk about rural area, we think only about the crop residue burning. So we thought, oh, is it the only scenario when the pollution is high? So we looked at then harvesting, residue burning, tillage, sowing, and during the pesticide spray. And you will see that all season they play a chemistry and there is a increased emissions. Either you talk before harvesting, during harvesting, and post-harvesting. So these are the work which are available, and this is how their emissions basically varied for various species. And then we also looked at fire count data and tried to understand how they are affecting the chemistry. Another interesting point is that when we talk about the air pollution, you will be surprised to note that AOD trend is changing much faster at rural location. Means they are the emerging hub. And when we saw India as a rural economy, we need to understand who will be paying the cost of the health. These are the rural population. And we should remain focused around there most of the time. So this is the work which highlights that it is not only basically this AOD change is faster in cities, but it is much faster in rural area. Then this is again, if I ask people where would you like to go, they will say at a rural site and say to relax. But look at the emissions. They were almost 1.5 times than the Chandigarh city. So this is where we sometimes have an impression, but which might not be true. So we also work on sensor monitoring side with Dr. Day. We have played some with Japanese colleague, with other colleague from USA and also from UK. So is this air pollution, is this only which we are talking, or there could be other sources? Yes, there are other sources, but if we look at, it is the indoor, where we are sitting now. What is forming there? And you will be surprised, there are 4 factors which will be affecting your health in that scenario. We were looking at the chemistry, but with chemistry, as highlighted by the chair, it is the how we behave. Means the social aspect, behavioral aspect, they will also affect. Means occupant behavior, outdoor climate, air exchange rate, and weather condition. And these pollutants you can also look at, and also some in the nanoparticles, like we hear during the COVID-19. Apart from indoor air pollution, I term this as separately as household air pollution. We know that in India, even more than 70% population is based on this solid biomass fuel. So, when you go to them and ask what is the health impact, they will say only respiratory issue, this study was published actually, or eye irritation. But if you go through the data and stat, you will see that total pollution is killing more than 10 million population. And if you look at indoor and outdoor air pollution, they are the #1 risk factor for our health. And then if you go further, you will see that against all this ischemic means cardiovascular disease, we are taking the burden of the death and disease. So we need to understand when we see the young deaths, they might be associated with air pollution. And 2011, Ella died, and 2021 it was said that she died because of the air pollution. Only 1 death till date because of the air pollution. That is global evidence. How many deaths? 1 death proven. So I ask you, is there any data? The government says there is no data because most of the studies, we, including myself or other colleagues basically, are working on correlation, not causation, or long-term evidences as we have from Pop and Dockery or other, you can say, cohort studies. But when we talk about indoor air pollution. As I said, because our rural, my talk will be focused on rural. Professor Padmavati, in 64 years back, basically proved that yes, those who use solid biofuel, they are exposed and they have poor pulmonary. It is a disease, cardiovascular disease, like in smokers. So they are exposed, and we don't have any rules and regulation still for indoor air pollution or indoor air, except WHO guideline for indoor air pollution. So how it is differ basically? You know that mostly it is through lungs, but it can also be through other way. Again, our occupation, how much we are exposed, means which activity we are doing. India is the only country where people feel proud that my house is just close to the road. Of course, if you are living close, you are exposed to high concentration of the pollutant. Traffic pattern, percent of other pollutant, which I learned here actually how that chemistry play. And again, I was listening the source to exposure, but no, it's from source. It is then emission, then concentration. Then concentration, you are exposed. Exposure at target order. And then where, which pathway it is affecting, and your health status along with other parameters basically, like age of the receptor, state of the health, duration of the exposure, concentration of the pollutant, and nature of the pollutant. The outcome will be defined. So there are various factors. Means there are various disease models which we can talk sometime. I can explain you from communicable to non-communicable disease how this focus. So we try to understand, and then we try to look at how much that at a rural location could be associated with the air pollution. So this is the same area which I showed you the slide, and here you can see on an average 250 excess death we could attribute it to the higher ambient air pollution at a rural site. So this is the first study from the India showing that yes, air pollution is related. Now, do you think this is fine? Look at the hospital admission data. When you say the air pollution is high, and when I try to relate it also, you will see that number of visitors are less. So means when people, we say, what we learned from other studies, increased hospital visit. But I remind you, this is a government hospital data. So civil hospital data. So you need to also explore these things. If you are doing a health risk assessment study, and if you only rely on a certain data. So what I am showing, these are the high, means high air pollution epicenter, and less people are going to the hospital. So there is no issue. The government is right. Basically, you have to go through this article and you will identify that it might be that these are sorters. They might be going to someone more local equator. And this happens quite frequently, and we try to report those. Apart from this, actually, our behavior has changed. From last 2 days, you know that we are sitting indoors, and on an average also, we are spending now more time in indoors. So 76%. So this is time when we are thinking, we need to understand how will be the air quality impacting us. So at our rural location again, having the rural women, we try to understand what will be the air pollution exposure. Again, at rural location, you cannot find one type of kitchen. Like you have various physical environment. Someone was studying in Himalaya, someone has stayed in Bay of Bengal or somewhere in coastal side and isolated side. Look at the type of the kitchen and then how the air pollution could impact. We were talking about indoor air quality standard, and here I am talking about the PM 2.5 concentration. Look at where it is 2.5 microgram, somewhere here. So how much we are exposed. I heard a lot about black carbon. And when I talk about black carbon, you will be surprised to know that the concentration was more than 25 microgram. Only the black carbon. Means here you are looking the concentration somewhere in 2000 microgram range. So think about how much, and again we did our study looking at 2 hour to 6 hour exposure. So this kitchen, accelerometer, black carbon measurement, and where from 6 to 35 microgram. This is only the black carbon. If the time will permit, I will show you the kitchen. The tar is, you can say from the wall you can see the tar. And then look at the impact. Anyway, the minimum, maximum, and average. So overall, if we look at, the concentration was relatively very high. We thought, okay, we have black carbon, let us relate it with the benzoyl. So we try to establish a kind of a, how much cancer we could attribute, because I look at the risk factor, and then I identified that if I consider black carbon as benzoyl, how many additional cancer, because this is the nearest I could find out. And then try to relate this crude death rate along with the population-based cancer registry. I hope you are aware that PGI Chandigarh is among the pioneers in leading the population-based cancer registry, through which you can verify your data also. Otherwise, most of this hospital-based cancer registry, which do not give you the better picture of the health risk. So this is the standardized cancer death as per our study, and this study published in Environmental International, and you can see. But here I will also bring an interesting finding. When I try to look at this excess death, yes, they are related. But, and they are matching, because overall death burden, it is 2% only, which we will give it to the cancer. So somehow, these burden are in the acceptable range as a public health professional. Where in a one death at 1 lakh population, if you cannot provide any solution, is acceptable. Like chlorine we give in the water, and that is also related with the cancer. So we need to further investigate, and my colleague is sitting here. What is this oxidative potential, or what is there, which we need to really understand, or where we are missing, because this data is thoroughly examined and presented here. And we did another study recently. Is this clean fuel, is it really improving the health of the woman, or it is depleting, or if other women are using, what is happening? So what we did is clean fuel and smoking women. We selected 3 locations in 3 states, having more than 3,000 households and women representatives. Our data, because we are also modeling and we will predict. So model has been developed and showing a good result. Interesting finding here. Means, of course, they vary from Uttar Pradesh, Punjab to Haryana to other place. But look at here. This is type of cooking fuel. Means those who are using this solid biomass fuel, they have higher risk or odds ratio basically of self-reported health outcome. Means their respiratory element is compromised. Another thing which you will see that we look at means which caste they belong. So the poorest of the poor, the socio-economical status was also found to be associated with the health outcome. Means we call them backward caste or whatever it is. So this shows that yes, there is an association. Another thing, in different states, looking at the basically type of the biomass fuel, we notice that age is also a factor. So in Punjab, you could see that they are reporting early. The health outcome is somewhere in 30 to 40 year of age group, whereas in Haryana or other, it could be the 40 to 50 year of age group. So this shows that yes, means if we provide the clean fuel, their life could be better. And that is why the government initiated several programs, and you are seeing that we have reached to the now this PMUI, and then there is a Solar Alliance also, which the first day the speaker were also talking about this sustainability, the sustainable development goal. So these are the impact which we looked at, and this is how we have reached to this barrier where this energy transition is happening, and if it's continue, we will be able to minimize this health and disease burden because of this, and we propose this how it could be ensured using this Keval model and then various programs. And if we give, means if we implement our policy, it's not always the dark side. Here you can see that the article is showing that if you implement your policy and planning at the ground level, you could have the positive outcome. So that and disease burden, which was reported somewhere here, is now reduced. So the positive policies work. Last So if we do this, basically, we can have a positive impact, and we need to work towards more the vulnerable, those who are, you can say, unaccessible, so that we can minimize their impact. So considering this, basically, I developed this health adaptation plan for Government of India. We were given this responsibility by National Center for Disease Control, and it was adopted by them. And I'm happy that I developed this, and which is being adopted by Government of India. Along with this, these two booklets like Health Sector Preparedness for Air Pollution, then what and how a medical professional can play their role to understand, means, and look at and relate air pollution with the health. So these are the booklets which you are also seeing, and they are part of the national program. So this is somewhere you feel proud, basically you develop something and become a national, part of the national program. So it's a small contribution from our side, and then another booklet to educate common man what is air pollution. You can look at the content. So our environmental minister and state minister at that time, they have released or forwarded it, basically, if you will go through. And then how people were asking so many questions. So then we developed this for the ministry also. And then I hope you are aware that we are the communicator through comics. So 42% population in India is children, means below 18. Some, let's say, so if you want to communicate, you can at least have 35% of your population to talk to them. So when COVID came, I developed this booklet, and along with our partner, we developed how to minimize air pollution around the school, and these two comics were released by Government of India. And the latest booklet I developed on climate change. You name your language and you will find that booklet. Probably if you can read your language, you can find it here. So they are available in more than 22 Indian languages, and international translation is in progress. So through these communication, basically, we are not creating awareness, but we are breaking them to them for certain action, and these actions are known as lifestyle for the environment, which is the Government of India initiative, Life for Life. Means lifestyle, how through modification in our daily life we care. So where the government is taking several initiatives, like I said, Solar Alliance to green energy, we as an individual can also contribute towards healthy living. Thank you.
Thank you, Professor Ravindra. Yes, question time now.
Thank you for such a vast topic to cover, and I have a comment. So you mentioned about the tar in rural areas. So women cooking, and you can see the. I think you're talking about the black soot, or what exactly you're mentioning about that?
Basically, that is tar.
Yeah.
And tar is nothing but black carbon, which is deposited on their wall.
So I have seen that in my house in Delhi as well. So that's why I wanted to
say that. Means we talk too much about black carbon. We are going to Himalaya also to measure that. But look at, means there you see only in small particles. But look at in the long term how much it is being deposited at their houses. Means so how much exposure could be there? You could simply look at their houses. You can imagine. But still, somehow the cancer risks somehow were not there. But when I'm saying cancer risk, they are again part of this total mortality burden is only out of this 2%. So I'm not denying that cardiovascular disease burden might be more.
Okay, and can I
Yeah.
There was also I couldn't get what is the odd ratio. Maybe I missed something on x-axis.
If you have healthy population and compared to that odd of disease, compared to that population basically in the person exposed to. So that means if odd ratio is 1, means there is no chances of having disease. But if it is posed more than that, it means there are odd of having that disease compared to non are that much basically. So 1.2 means you can say that roughly if there are 100 people, so there will be chances that 2 people will get that disease, something like that.
Okay. Thank you.
Okay. Thank you, Professor. Okay, our next speaker, Professor Sagnik Day, and he's talking about how we are looking beyond PM Mars.
Okay, thank you. Yeah, so I want to express my thanks to BJ for inviting me. It's really great learning, listening to all these important talks. And Dr. Khaiwal has already provided a very good overview of the air pollution and health scenario in the country, covering multiple topics. So my talk is focusing mostly on the argument that we should start looking beyond PM mass-based indicators when it comes to the health impacts. And I acknowledge the contributions from my research group, Dr. Santu, with whom I'm collaborating, and many other colleagues. So just two examples. We all know that WHO has various interim targets as well as the air quality guideline, and I'm mainly talking about today on PM 2.5. And if you look at all the important interim targets, all the way down to the air quality guideline at annual scale, which is 5 microgram per cubic meter, these are all PM mass-based thresholds. If you talk about our own national standard for PM 2.5 at annual scale, it's 40 microgram per meter cube. WHO interim targets and air quality guidelines are mostly based on the cohort studies done across the world. When the Central Pollution Control Board defined the national standard way back in 2009, there was no study actually published on PM 2.5. Papa study which Dr. Santu was involved, that it was going on. Perhaps the first report came out in 2009 or 2010 or 2008, yeah, so almost the same time. Oh, 10, yeah. So this number has no scientific backing. Why the national standard was set at 40 microgram, but now, as we speak today, CPCB is in the process of revising the national standard. And then obviously you have the different 24-hour standards. Then the other important point is that we talk about the global burden of disease. I was part of it from the India arm, where exposure, rather long-term exposure impact on non-communicable diseases are quantified. And if you see the methodology there, what they do is basically they calculate the excess mortality or morbidity attributable to different diseases. So for example, so far the relative risks are available for COPD, ischemic heart disease, stroke, LRI, lower respiratory infection, type 2 diabetes, and preterm birth. So these are the 6 diseases which are part of the GBD because there are enough cohort studies to define those response functions. Now, I must say that there are many other diseases for which air pollution impact has been identified globally, including in India, but enough cohort studies are not available to really develop the integrated exposure response function. So that is why they are not yet part of the GBD. And how do we calculate the excess mortality attributable to air pollution? So you calculate the attributable fraction, which is basically a function of the relative risk. So any given exposure, you can calculate the risk. If you have these functions, then you can calculate the attributable fraction, you multiply by that baseline mortality and the population, and that gives you how much of the total burden of that particular disease you can attribute to air pollution. If you have to do this for smoking, same methodology, all you have to do is actually you need to know what is the attributable fraction for that particular disease to smoking. So the point I'm trying to make again here is that all these things have very important assumptions. The first assumption is that the epidemiological risk only varies with PM exposure and not with compositions. So what is assumed is that the relative risk at any given exposure does not change if the composition changes. So we are assuming uniform toxicity. And secondly, for long-term exposure, particularly what we assume is that if we have long doses of low exposure, versus a situation where you have relatively low dose and then suddenly you have high spikes of exposure. So there is no difference. So these are the two basic assumptions. But this is the main assumption where I want to draw your attention. Question is that whether this assumption is correct, and also that what is the air quality guideline. As I mentioned, WHO has said 5 microgram per cubic meter annual PM 2.5 level. Is it really possible to achieve? Very recently a study has been published by Siddhant, and what they have done is this is a modeling study. So they have switched off all the anthropogenic emissions globally. No anthropogenic emissions whatsoever globally, and then this is what the PM 2.5 annual values, and you can clearly see that most of the countries, the PM 2.5 value is above 5 microgram per cubic meter. Entire India is above 5. So it's very clear that whatever we do, we can never reach WHO air quality guideline of 5. You have that much natural PM 2.5 present always in the air. So really the question is that then shall we really try to achieve 5, or we set more realistic target, keeping in mind that uniform toxicity assumption is not true. That's what the research is suggesting. So what is the way forward? So way forward, obviously you have to answer the question whether PM composition matters. And how to answer the question in terms of health, Dr. Khaiwal has already mentioned, so you can do different types of studies to generate indigenous evidence. You can think of doing time series studies to see the impact of acute exposure. You can think of also doing cross-sectional study first to establish association, and then for causality, you have to go to cohort studies. Now, when I started this work a decade back, I was sort of told that where the health data will come from. But now I realize that there's a lot of health data available. The real challenge is actually the representative exposure data availability. Now, why I feel this is a challenge? Because you think of any of these studies, it requires consistent, long-term, a very robust exposure data. Because if you're talking about cross-sectional study, you need data for the entire country, or at least in a very large regional scale. You may be measuring at 1 or 2 locations, and then think of doing again, some time series studies, but that will not really give you the impact assessment for the long-term exposures. So there are many challenges, and because India has a very inadequate, I would say, network for PM 2.5, even if I talk about today, we have around 400 continuous monitoring sites for PM 2.5 measurements. Most of these sites actually became operational after 2018. So if you go back in time, there are hardly any monitoring sites, and even today also we have no reference gate monitoring maintained by the government in the rural regions. Only few, as Dr. Khaiwal mentioned, are being maintained by different research groups. So what we did is that actually we developed the satellite-derived PM 2.5 database for the Central Pollution Control Board. So our data is at 1 kilometer spatial scale and 24-hour average values for the last 22-23 years. Now, one important point I want to mention that when we derive PM 2.5 from satellite AOD, the most important thing is to fill the AOD sampling gap at Delhi scale. We all know that passive sensors, when they retrieve AOD, they cannot retrieve on the days when it is cloudy. And it means that if you simply miss those sampling clean days, your annual statistics will be biased towards polluted. And this is exactly what we have quantified, and in fact we have developed a machine learning algorithm to first fill the daily AOD gap. So this is actually unfilled AOD average over the last I think 7 years, and this is the field. You can see that there is a clear bias, and then when you convert this to surface PM 2.5 unfilled data versus field data, interestingly what we have found is that because you are missing those better days in your sampling, your annual PM 2.5 exposure is overestimated by at least 20 to 30 microgram per cubic meter, and that's a very, very large number. So if your exposure is overestimated, then you can think of how much actually the downstream applications will be impacted. And this is the kind of performance of our daily product, monthly and an annual scale. You can see that the error is pretty much lower. I'm just showing the recent results because on the morning I listened to many talks which shows that there is an increase in the aerosol loading over the Indian continent from early 2000 to 2016 and 17. I am showing the data from 2017 to 2020 to the last 6-7 years of data. 6 years. This is not AOD, this is PM 2.5. And this is actually the distribution of the population weighted exposure. What essentially you see that if I calculate what fraction of population is exceeding the national standard of 40, interestingly you can see that number has come down in most recent years. And if you look at the satellite data or even the ground-based measurements both from continuous sites and manual sites mentioned by the CPCB, you will see at annual scale in more recent years PM 2.5 levels in most of the cities are decreased. If you don't believe me, just look at the data. Because we always think that pollution level keeps on increasing, but I must say that not just our data, very recently Ministry has also reviewed the NCAP activities and most of the cities have shown an improvement in terms of air quality, both in terms of annual average as well as the number of clean days or good days. So the next challenge is that, okay, this is the total PM 2.5, but my original point was that how we can really talk about the composition and look beyond. So that's even more challenging. So what we do is that we take this PM 2.5 satellite data because we wanted to develop database for the entire country. However, satellite cannot give you the composition directly. So what we did is that we collaborated with people who ran the chemical transport model, and from the model we got the mass fraction of individual species. So we simply, and because actually the models have also uncertainty due to the uncertainty in the emission inventory and other factors, we assume that the model derived mass fraction will at least be correct, if not the absolute value. So we then multiplied this mass fraction from the model of each species with the total PM 2.5 from satellite data, and then we get basically the individual species information. And this is just an example for, this is for 2015 and 16, so you can see that this is the typical black carbon exposure. This is the organic carbon, sulfate, dust, and sea salt, and then now we have more species. We tried to sort of compare our modeled exposure versus very few ground measurements, whatever data we could get, and we are still trying to get more and more data to improve, but at least for black carbon, organic carbon, and sulfate from literature, overall our correlation coefficient is 0.8. We hope that, obviously, it can definitely be improved with more data filtering in. But since we have this data, then we did series of different analysis. So this is one example of acute exposure analysis with PM 2.5. So first what I'm showing here is that in literature we find in many cities with PM10 data, people have looked into what is the impact of increase in PM10 on all-cause mortality. Very interesting thing, if you see that some of the cities which are polluted, I was just discussing with Dr. Santu, that when it comes to acute exposure, if the city is already polluted, then the sensitivity of the people's response to spikes in shorter term to the pollution level is much lower. Rather, what you see is that in the cleaner region, the impact is much more. Like, for example, Chennai or Simla is showing much higher impact than Delhi and other places. Now, if you compare with PM10, what is the situation with PM 2.5, for which studies are available from Delhi and from Varanasi. So Varanasi study, again, Dr. Santu is involved. So you can clearly see, first of all, in Delhi, we have both PM10 results from Papa study and PM 2.5. So PM 2.5 impact is much larger than PM10, so that is very clear. But then we also ask the question that whether there is differential association with PM species, and that's the next study that we did, and you can see here that we looked into multiple species, and very clearly what is emerging. So for each of these species, we looked for male and female. Same thing, all-cause mortality data. Essentially, the take-home message from here is that there are differential associations. If you identify which species has stronger association and larger association, you will see mostly it is black carbon and the secondary particles like sulfate or ammonium sulfate, whatever form you take, ammonium nitrate and others. This is for the short term. Then we did some analysis with the in a cross-sectional study design, utilizing the data from the National Family Health Survey. Anemia is one of them. And the reason anemia is chosen is that India has one of the highest anemia burden as per the statistics. So after adjusting all the important confounders, what we found is that first, with total PM2.5, increase in 10 microgram per cubic meter exposure leads to almost 7% increase in anemia prevalence in the women. And then we also then looked into is there any differential association, and again you can see that between these 5 species, clearly sulfate and black carbon is showing higher impact than some of the other species. And then this kind of analysis has been repeated from some other health outcomes. So here is the most recent analysis that Dr. Santu and my group have done together, where 3 different child health outcomes we have taken. One is the low birth weight, child anemia, and acute respiratory infection. And again, after adjusting for all the confounding factors, exposure assignment strategy is slightly different when it comes to the child. So for low birth weight, we have considered the exposure during the pregnancy, so that we can see the impact of exposure during pregnancy on the birth weight of the child when the child is born. For anemia and acute respiratory infection, the exposure is basically from the day the child is born till the survey was done and the results are available. So again, the main message here is that you see differential impact. For example, here again, the ammonium sulfate, nitrate, EC has little bit higher impact. And because we know that the species can be tagged to the sources, so when you do the analysis with different sources now, you see basically a similar result. So this points out clearly that there are differential impacts, or association rather I should say. So why is that? So if you look into the literature again, the biological pathways, unfortunately in India for composition there is no study so far. We need to definitely do that study, but if you dig into the literature and see elsewhere, then there are many studies which have clearly shown how biological systems respond to such differences in the composition. And this study is from Park et al., where they have shown that, so simply actually if the circle is larger, the toxicity level impact is much more, the response of the biological system. So clearly what they have identified is that, for example, diesel generators, coal combustion and all have much larger impact for different, biological responses. So it is very clear that different composition has different toxicity level. However, we are yet to reach consensus on which particles are more toxic across a wide spectrum of health impacts. But there is no denial of the fact that PM composition matters when it comes to health impacts. Now, even if you move ahead of PM or PM compositions, the next question comes that air pollution is always a deadly cocktail of various components. It's not just PM, you have various gases and others. So, if that is the situation, then whatever association or causality you are establishing with PM, it may be modulated by other gaseous pollutants. So, what is important from India is that we need to go in a multi-pollutant environment and start looking into this. Now, for that again, what is required is exposure data for all other pollutants. And one such pollutant is NO2. So, recently we sort of looked into the long-term changes in NO2 columnar concentrations and try to understand where the NO2 columnar concentration is higher, and you can see that wherever you see big power plants or the big cities, you have high NO2 concentrations. And now, using such kind of satellite data, you have developed a land use regression model to estimate the NO2 surface exposure at a very high resolution of 100 meter by 100 meter. This is done done at annual scale for 2015 onwards. We did not go back to 2015, but if required, we can go. And then you can see sort of that, again, it's a very quite good comparison with the ground measurements, but then if you just blow up the big cities, Delhi, Mumbai, Kolkata, and Chennai, you can see that in those cities, most of the regions are actually exceeding the national standard. And if you keep in mind the WHO air quality guideline of 10, which is for NO2, then a large part of the country is actually exceeding. So what is the way forward? My last slide. What I feel is that we need to create consistent, robust, and long-term exposure database for PM species and other pollutants, so that the health studies can be done in a consistent manner across different timelines. Because we also need to understand whether the health impacts are changing over a timeline, as various other factors also impact those, which Dr. Santu will talk about. And as Dr. Rastogi mentioned earlier, I think this is the key actually, that we must link to oxidative potential and understand the biological response. And if we cannot do that, then whatever policy we are framing is meaningless. And we need actually systematic epidemiological studies with as much as possible indigenous health data, because this is one of the key things always coming from the policymaker. Where is the evidence? I showed that there are evidences which cannot be ignored because these are all Indian data. Finally, we need to set realistic linear target. We cannot really, target dust. And if you talk about the national linear program, you will mostly see what we are doing is controlling dust. We forget about fine particles, diesel generation, and many other actually, which are the toxic sources. And finally, those mitigation efforts to be prioritized where we know that toxic particles are being emitted, and clearly there should be a demonstration that air pollution mitigation efforts are leading to health benefits. So with that, I end my presentation. Thanks for your attention.
Yeah, thank you, Professor Day, for this nice talk. And now the question time, please.
A very nice talk. I think both the statements are correct. For example, that AOD is increasing. We all know that, and several reports are telling. What the statement you are telling, PM 2.5 is decreasing. Please note that AOD is the integration from the top of the atmosphere. In the changing climate, the recent trend, the trends has been changed. The free tropospheric aerosol concentration has increased. So that will not come into the PM 2.5 what you are mentioning. I think both the statements are correct. Using RF network, SPL people, and from Gadenki observations also, we have shown that in the recent times, there is a decrease in trend in the BC, and also, of course, though it is a part of a fraction of in the total aerosol, but there are decreasing trends in the surface, but increasing trends in the free troposphere. So that will reflect in the AOD. So we should keep in mind that these two are two different aspects.
No, absolutely. I mean, but my point here is that when it comes to air pollution, and particularly for exposure modeling, usually, when you try to convert AOD to surface PM 2.5, it was not done, adequately. And many data sets I have seen actually where PM 2.5 surface estimation is highly overestimated, because you don't really adjust to the particle distribution.
Yeah. Yeah,
Just
there is another
one
question.
comment. Because actually, in the final slide, you are addressing that. So when you are showing the composition, means say sulfate, nitrate, ammonium, we know that they are the part of PM 2.5, and more or less they're not too much variable. So that means if it is you get the relation with the PM 2.5, you will get with those component also. But actually, if we are looking for the species actually which are causing oxidative potential, that you have already said in that. So in that, black carbon may be interesting thing, because that is the means it represents the combustion, and from combustion many of the reactive oxidations also.
Yeah.
So among them, black carbon is the most realistic.
No, absolutely. I mean, so it is just a beginning. Even in organics also, there are studies globally, not from India, that soa is much more toxic than primary organics and all. So organics, when you say, it's also of different types, and then you need to really differentiate
Yeah, Doctor.
Thanks for a very nice talk. Europe is currently revising their air quality guidelines. And in these guidelines, at the moment, the proposal is that they're going to add, first of all, black carbon as one of the substances to be measured, oxidative potential, and concentration of ultrafine particles. These are not going to be regulated at this moment, because first what they want to do is they want to collect the exposure data. So maybe that's something to consider, and then of course follow what's happening then in Europe in the future for that.
No, absolutely. I think very good point. I mean, probably in future things will be considered, but currently the CPCB is already in the process of revising it based on whatever knowledge we have. But yeah, absolutely agree.
Professor Day, I have a small comment and the question also. Giving a little bit background, Professor Smith, he started to work in 1990s in India, and he already started with a couple of things, but still, what's your take on how we stand on the estimating the toxicological curve? Because that's based upon the kind of sensitivity of the individual, one thing. Second, still he raised this point in 1990s that we need to have a cohort study because we are missing, and Professor Balakrishnan was part of those discussions. But still we are at the same pace. So what's your take forward in terms of establishing something related to cohort studies and having the toxicological curve, what Professor Rastogi also mentioned about the different compositions. And I'm looking forward to see in depth basically all these toxicological curve and how we can build into ICRP model all these things basically from the Indian perspective.
Yeah, I mean, again, absolutely agree. Whenever we discussed with Scott, those are the discussions. He used to say that we should move from source apportionment to exposure apportionment because that's where the impact is. Yeah, coming back to the point is that, yeah, I mean, if you look around the typical research going on in the health field, funding, long-term commitment to the funding is a big constraint for cohort studies. Still, there are, I think, a few cohorts which are either recently indexed or still continuing. There are opportunities now if you have this sort of exposure data. You can sort of add air pollution as an as a risk factor and do retrospective analysis for the cohorts for which already the health data is available. I don't. So only probably one happening and some other cohorts are going on where directly they are actually assessing the exposure, but again, not from the toxicity perspective, it's just the total exposure to different pollutants. So the research community is trying to convince health ministry that these are important things, and in CDC I think they are kind of agreeing that we need to really move beyond this traditional standardized metrics and do more. I hope that in future we should start long-term cohorts.
Yeah. And I believe the cancer registry data also if can be maintained, because still we are not established a kind of linking which is based upon the international scenarios. I think you are the key person to take it forward with Professor Balakrishnan. Yeah, thanks for a nice talk. Okay, now for this session we have the final talk from Professor Santu, and we believe that we will understand more epidemiology from him.
Middle pointer, right? Okay. Good afternoon, all. Thank you very much, Dr. Bijay, for inviting this session, this seminar. And from the morning I was listening. I was not fully awed because 12 years I was with Kalpana, and that has a multiple wings actually. So I love to listen, even that is beyond my expertise, because sometimes that gives motivation for my research. So that's why I loved him. In few days before, suddenly, accidentally, I entered into AI community. And that whole sessions I listened and found some motivation. So anyway, I mean, already Ravindra and Sagnik said the platform, so I don't need to say about Air Pollution and Health Association and its pathways. Rather directly, I am going to acknowledge some studies that have been already published and available in the literature. Not all, but whatever I could collected through Google are going to summarize here, and it's just an acknowledgement, not a depth exploration of those studies, how it was done, but definitely we'll summarize from what we learned from here. So if you look at the air pollution literature, even recently the air pollution has been a major public health concern for so many years. And that recently, last few years when Delhi seeing this high pollution, people had started considering air pollution is a problem to our life. But it was there. In 2018, they said that around 9 million premature deaths worldwide, with India accounting a significant proportion of these deaths due to this air pollution. And 2019, 1.67 million deaths in India are attributable to air pollution, accounting for 17.8% of the total deaths in India. That is also Lancet Planetary Health 2021. That paper was cited by Ravindra also. And a study collected data from 25 cities in India reported, even forget about others, in recent, there is a direct link of PM 2.5 and COVID mortality. And same, Lancet Planetary Health reported the lost output from premature deaths and morbidity attributable to air pollution around, say, $28.8 billion and $8 billion respectively in India 2019. So it's one of the important factor at present to our day-to-day life that need to be mitigated, but nobody knows where is the solution. So let's focus on air pollution health, and then which are the health problems that normally people get. So based on the literature, these are few, there are many. Even recently I was getting some articles, I guess from the same Chinese group, somebody is trying to see the old age fall with air pollution, somebody trying to associate with GI with air pollution, and many other. So people are exploring. But these are something very common, is the respiratory, cardiovascular, neurological, reproductive age, cancer, reproductive outcome, cancer, eye and skin, these are mainly the acute impact. So these are the main focus health area where air pollution can impact. And now we'll see where we are in terms of the evidence base. I don't focus much on below 2019 because this is one article that is published in 2019, is beautifully actually capture all the studies before 2018 and 2019. So there are 59 studies in 2015 when I was summarizing my PhD, it was around 46 or 43, I can recall. 46 could be. So after that, this many happened. So 59. So I'm not focusing on these studies. Those who are interested to get the evidence about air pollution health, you can read this study. But I will focus more on what is the recent evidence that we have, touching few that are important from this pool. So Lancet Planetary Health 2021 estimated that air pollution is responsible for 1.6 million premature deaths in India every year with respiratory illness. And a recent study, SELVI 2021, compared self-reported respiratory symptoms of school-going adolescents between Delhi and Kota, Mysore. I feel this study is very important, though it's not actual comparison or actual exposure response association between PM 2.5 or any air pollution in this, but in epidemiological literature, this is one of the important aspects when you have a counterfactual, you have the exposure, and you need to show that where counterfactual no effect, where you have exposure, you have a effect. But in an air pollution literature, it's really difficult to find a counterfactual. And that's why, we consider still now that cohort is the gold standard for air pollution epidemiology, not randomized control trial, which in general is a gold standard to prove any causality. Because randomized control trial would be merely possible in this particular literature, this particular field of study. Because, everybody exposed to air pollution. You cannot reduce air pollution even below 5, whatever way you try being in India. So you cannot find a true counterfactual here. So these study particularly compare two cities. One is very low, another is very high, two extreme of our country, because southern cities are much more cleaner. Even Mysore is one of the non-metro cities, so naturally they are much cleaner compared to Bangalore. So when it is compared, they found that asthma, respiratory symptoms, allergic rhinitis, eczema were much higher in proportion in Delhi than Mysore. That's why I'm telling I feel that is a very important evidence, because when you have a 2, it is almost, if we assume that's near counterfactual and another is really highly exposed, and you find a clear difference that itself proof a bit about the causality. And when talk about lung, the Ranjini et al. 2022, they published a study that is called APCANS here in Andhra Pradesh. And so this is not Andhra Pradesh now, sorry. It was. They reported that there was a decline in actually lung function. I'm not going in details. The details numbers are there. Those who are interested can read. They reported that there is a decline of lung function that is measured in terms of FPV1 and FVC, actually the forced expiratory volume in the first second. And this is kind of marker, that lung marker that help to understand the outcome or lung function. So that found to be declined by higher PM2.5 exposure. This is one of the important evidence, and it was a cohort. Then talk about COPD and air pollution. The Suryakant et al. 2022 reported the impact of use of biomass fuel on COPD among non-smoker, because that was a case control study and they excluded all non-smoker. Shows a higher, proportion in, higher odds of COPD, those who are actually biomass cooking fuel than non-biomass cooking fuel. And the odds ratio was reported by 4.25. Somebody was asking about odd ratio, right? It was nothing but the ratio of two odds. For your understanding, I would say if you can consider a risk. Risk means, you have a two group, and one group is this many cases and one group is this many cases. So if you get the proportion, the exposed group must have a higher proportion and unexposed group must have a lower proportion. So how do you get the excess risk? The proportion is the risk, but how do you get the excess risk? Two ways you can get. One is in additive sense, and another it could be multiplicative sense. Additive sense means you can just subtract to risk and you can measure the excess risk. Or you can take the ratio and you can get the risk in multiplicative term. So odd ratio is equivalent to relative risk, you can consider. And then even this is another study that it is not a study, it's a almost the prospective paper where they mention that given the alarming increase in prevalence of COPD among non-smoker in recent past, a potential role of air pollution, particularly particulate matter in COPD developed, has gained much attention of the scientists. Because before that, people used to take COPD means smoker. The smoking, it's considered to be COPD. Even if 65 years old is chain smoker, if you go to a physician, they would first write COPD without any investigation, because he was a chain smoker. So that is it. I have seen several times. So, but now the number of the COPD among non-smokers are increasing. That itself indicating the air pollution could be, a major risk. That a Kark used to say, the household air pollution is equivalent to that many cigarette smoking. Then ARI is a recent study, Bala Subramaniam et al. 2022. They published based on the NFHS data with the global estimate of PM 2.5, and they also found the increase in, say almost 0.6% rate ARI cases increased by 0.6% per microgram increase of PM 2.5. And what they did here, they actually standardized the ARI prevalence by the prevalence per square kilometer. And then this is the global estimate PM 2.5, and if you see, you would see the clear trend between these two. So though it is a correlation, but actually giving some evidence that it is a causal based on the evidence that we get from the global database. I mean, it would be foolish to consider we are a different species than those who are living in Europe and America. So I would suggest, do not run behind collecting evidence, that rather try to quantify the evidence for a better policy making. There is another study where Sagnik was involved. It was not fully Indian, 35 countries, and you see how close the estimate is. The estimate is almost similar. So that India was one of the study, and they reported per 10 microgram increase in PM 2.5 was associated with odds of having ARI, that is almost 6% increase in odds per 10 microgram per meter cube increase. So here it was 0.6 per 1. If you multiply by 10, you will get 6. So both studies giving almost same estimate. There are very few evidence of cardiovascular illness, but there are sufficient global evidence nowadays, even in the cohorts, by a cohort study. So almost globally we can consider that this is a causal, but in India evidence are very, very few. The one study, same APCON actually, they had some, cardiovascular marker, which is the CIMT, that is the carotene intimate media thickness, which is the marker of erythroclerosis. It is not a good marker. However, it could be considered as a marker, but not as a diagnostic sense. But for a correlational sense, you can think as a, to understand the association between air pollution and CIMT. But it is not a, correlation is not so good so far that I observe. But however, this is one of the evidence that they reported positive, the association of CIMT with PM 2.5. And that was, they did lot of things, they did land use regression and many other way they estimated the PM 2.5 for, yeah. Hypertension and air pollution, there are two studies that I found. One is the PHFI Prabhakaran and another is the Kalpana's, the Happin cohort. They also showed that there is an association between increase of blood pressure and air pollution. Very limited information about cognitive health and air pollution in India. However, there are two studies that I found is that also showed the higher risk of cognitive health, cognitive decline with increase of air pollution. One is a Krishnamurthy et al. 2028, and another the Lassie study, the famous Lassie cohort, that is the longitudinal aging study in India. Then child development and air pollution, there are few studies that, there are a couple of studies with NFHS 4 itself, and this study also showed that the child satellite-based PM 2.5 actually, that is also the global estimate, I think. The reported increased average concentration of fine particulate matter by standard deviation account almost 5 and 2.4%, increase in stunting and severe stunting rates. The reproduction health with birth weight, this is another study that actually there are two studies that I found. Islam Mohanty 2021 showed a significant association. Almost, they showed an 80 gram higher weight among clean fuel versus non-clean fuel. And Goel and Canling 2021, they found a nonlinear association. They found at different level of exposure, the effect is actually increasing. Then this is, Kalpana and I was involved, this study estimated almost 4 gram decline of birth weight per 10 microgram increase of PM 2.5. It is a cohort, so this is much more, robust evidence. However, this is one randomized control trial by Kalpana and other partners. It shows actually there is no benefit giving LPG to the pregnant mother. Look at the journal where it is published. However, they reported that they found a positive association with actual PM 2.5 concentration. When continuous exposure response was associated, they found the association. But actual benefit was nothing. Let's focus few minutes on some time series study, starting from Papa study that was Chennai and Delhi. Then few other study, including what Sagnik also reported, the Ahmedabad study. One of my junior took my health. There are 5 cities showed impact, and as Sagnik already covered, that where the exposure is less, effect is much higher, so I am not touching upon. Then 2 recent study, where parallelly we did, I and Sagnik did one, and PHFI did, that also showed almost similar effect. Only the numbers will vary because the exposure levels are different that they consider. They consider interquartile range, we consider 10 microgram per meter cube. So that's the only difference. Sagnik already talked about this study where we explore further details with the PM species. Then another one, that the evidence of anemia and air pollution, that before that there was little evidence, was not so robust, yet the causality is not established. However, we can consider this is the association. It's long way to go to establish this association. This is for under 5. This was for WRA, women of reproductive age, that he already spoke. And this is the final one that he was talking about, that we also explore the 3 different children health outcomes with the PM species and the fraction shared by different sources. In conclusion, the local evidence of air pollution and health effects in India is improving over time, but yet to focus on many other factors like cancer, like neurological disorder, like coronary artery disease. The premature CAD is one of the emerging concerns in our country. Metabolic disorder. The PHFI is doing the study, but I didn't find, they have not published, I guess. But metabolic disorder and the cardiometabolic risk factor and air pollution, that is what they are doing. They published the methodological paper, but I have not seen the actual results. And recent priority should be quantify the association that I told, that where the evidence is there globally. We just need to quantify for, plan our, policy correctly for the implementation. And considering variation of these acute effects that Sagnik shown, that itself is telling we should decentralize our study across the geography to understand the entire spectrum of the air pollution health effects. And finally, the inflammatory pathway, which is mediated by the oxidative stress, is a most explained physiological pathway for air pollution and health effects, where antioxidant may play a very vital role. So we really need to explore this particular link till we can cut down our air pollution below 5 microgram per meter cube, where nearly impossible in next 50 years, I guess. Thank you very much. I took more time.
Yeah. Thank you, Professor Shanto. Now the questions, please.
Good?
Okay.
Yeah,
can I-
sure, please.
Mechanism is when you are seeing the kind of linkages between PM 2.5 and different.
Don't study yet. You know that the problem is the health science people should come up. Okay, and this mechanism, you know, it should be a physiological mechanism need to be established. You know, I feel it is not only the physiological mechanism of PM 2.5. You know, we should focus more in depth with actual species, your oxidative potential, all together need to be explored. You know, I think, you know, you correctly pointed out that it's long before that was discussed, but nothing progressed actually. So that need to be actually established. We are mainly focusing on epidemiological studies. You know, epidemiological studies cannot give us a proper mitigation strategy. We have to understand the physiological mechanism, and unless that happens, it's really difficult. You know, that is needed. Yeah, these are require more trained people. There are very limited people who are interested in environmental, you know, epidemiology itself, and then even the physicians has to come up. And the problem for environmental epidemiology is a bit complicated.
That is correct.
Okay, the whole mechanism is complicated. So people are not much interested to enter into this complex life. So that, unless that happens, we really cannot solve whole the problem. I mean, it would be only the problem would be solved superficially. At the end, the problem would be as is.
Yeah.
I'm quick to add that. So yeah, so for this anemia work, actually, they have given a hypothesis on this physiological pathway, and that can be tested in a cohort setting if you have those biomarkers and all. So that is what is required actually.
But there are some groups who are actually trying. Even my own group, Kalpana's group, they are also trying. But many groups has to come up with this. You know, I being a environmental scientist or Sagnik being a, you know, exposure scientist cannot solve this problem. It is beyond our cup of tea. We only can help, but a core health science people should come up, because the physiological mechanism is beyond our, you know, thought. We don't know.
Professor Andu, a small comment.
Yes.
In addition to PM composition, how do you see in Indian perspective the size distribution and having this LDSA kind of studies so that you can estimate the lung deposition?
Yeah, of course, you know, that will help. But, you know, if you are looking for actual species, why do you need to bother about the size? Because this is an alternative. We are trying to explore the actual composition.
Size may matter because
if you see, sorry, yeah, please.
If you are talking about certain transmitters. Depending on, you know, when you are in air, size will decide how deep it can reach.
But that is PM. But when you come to the molecule,
That molecule is a part of that PM, right?
Can I just add on quickly?
Yeah.
Because our respiratory system, it depends upon the impaction, and there are, what the processes are taking place in atmosphere. I'm just adding, please listen. Quickly, because the respiratory tract it's basically works on impaction, deposition, couple of phenomena are there, and the size distribution, it varies. If you have less than PM1, that get deposited more, and in between it bounce back. So that depends upon how the toxic, in addition to size, the composition again is very important, because nowadays we have the analytical skills so that down to PM1 we can make the composition also. So I think combination of these two in addition to dose curve analysis will give a kind of very much understanding about the exposure.
Agree.
Yeah, so in IIT Delhi, actually, two of my colleagues actually did one small experiment where they found that particles smaller than 0.25. So they call PM 0.25. It's 5 times more toxic than PM 2.5. So right now it's not actually, I mean, nobody is actually giving much importance, but probably yes, because size in a way also is related to species toxicity and all. We need to explore that.
Yeah, I'm not ignoring that part. You consider respiratory tract as an ambient environment.
I'm not ignoring that, but it's, we can.
Smaller the particle,
Thank you.
deeper it
Yeah.
can reach. So I think we should be concerned composition of the smaller particle, probably. The larger particle may not reach deep. Yes. Different places. Yeah, different places. But not way to be.
Thank you, all the speakers. Please applause for all the three speakers. Thank you.
Yeah, thank you, Rakesh, for chairing the session. And I thank one and all the speakers, delegates, everybody, for keeping to the time. We finished 5 minutes early. That's great. So as you see in the program, we don't have a formal valedictory function. What we have is a closing session. The way we planned is we'll have a maybe kind of a round table. No, it's not round table, but yeah, open discussion for outcomes and the way forward. We have prepared a short document, and now I will request Dr. Antti to chair that particular session, and then followed by we'll have a best poster prize prize distribution. Professor Ghanshyam Krishna, he has to attend a meeting, so he won't be joining us. So we'll not have a remarks by Professor Ghanshyam Krishna. We'll directly go for a vote of thanks then. Yeah. Over to you, Antti.
How long do you want this to?
We can have as long as we want to. I think half an hour, 20 minutes, absolutely fine. Yeah.
Okay, so now we've heard very many talks, good and excellent talks, and the organizers have here listed some of the, let's say, notifications that they have made during the talks, what are the important points, and what we were asked actually in the very first session was that we should come up with some kind of a way forward, and why do we do these studies, and what should be the objective of them, and how do we go about in the future so that we can maximize the results of this symposium, so that it's not only, as it was said, whining and dining, but actually there are some concrete results. And now in this session, we will go through these notifications that were made during the last 2 days, a little bit, and then there's open discussion from you. So what do you see the points that are important that we should have in our final sort of white paper of recommendations for the way forward, and what should basically be the concrete steps as well. And I think that the organizers then, after the symposium, will pull this white paper together for everybody to circulate. Okay, so how do you want to show this? There are 3 pages now of different ways of doing that.
I don't think we can squeeze into 3 pages.
No, we can't.
We can go through point by point maybe. No, we can't.
Okay, let's do it such way that I will follow the document at the same time, and I will take your comments, and then if the comment is already there, then I will emphasize or make some mark that this is especially important, and if there are new comments, then we will add it to the document.
You have most of them are here now.
Okay, so floor is now open. What do you see that was maybe the most important finding or of this symposium? And
don't make that kind of code.
Yeah, but it's also open with the senior colleagues here to suggest what would be the best effective way.
So I think the best effective way would be, so DST, MOES, MOFCC, Health Ministry, 4 ministries definitely, and then think tanks like NITI Aayog and PSL. Probably it will be best is that if these points can be sort of summarized and linked to the ongoing programs of those ministries. Because otherwise then it looks like these are required. For example, MOFCC has already program, National Clean Air Program. So under that which will be important. EST is also having a program on climate change, of which aerosol climate interaction is very important. Similarly, that all the points regarding to nanoparticle formation and all perhaps also could go there. MOES is also, again in MOES has different programs. So my point is that this can be grouped and then linked to the ongoing programs, and if we feel that focused network program is required to be created to address some of these issues, that also can be suggested.
I think that's a very good suggestion. Should do that. Yeah, we can differentiate and then we can try to link with them. Yeah. So at least it will work with not all ministries, but maybe at one of the ministries.
Yeah.
So that will also help. Yeah. Then we can approach different ministries and
And then say that this is the program you are already having, and this is the is required to be added for.
The way I see it is that we have findings that we have made during this symposium. We have open questions that we have found that need to be addressed. And then, let's say, we as a community are trying to come up with recommendations of what should be done. Sagnik.
Also one more point. Sorry. The DST, Department of Science and Technology, is coming up with a research vision document. So this is 2030 and beyond. What are the immediate action item? And under that, focusing on the climate. So you can share this with them also. And I know that you are also part of that. So you know that there are different sections already identified within that what area India should invest in. And that document will be followed by all the ministries once it is finalized.
So more comments or notices now from the audience. Please wait for the mic.
So you said, going through those points, and if I really resemble so I think there was something about nitrogen. I definitely would say that highlight that. Yeah, exactly. So that's definitely very important.
Good.
Sorry, one more point is coming to
Yeah. Don't
so
hesitate.
what I'm seeing here is missing is that I personally think in India we don't have adequate capacity. Even very few groups actually are capable of doing this kind of advanced measurements and all. So capacity building in aerosol measurements should also be a very important point. It's not just the science, but science cannot be done with enough groups actually capable of doing those measurements. Okay,
Yeah, but so not just the aerosol science, or maybe the atmospheric measurement. Yeah.
Yeah, so the objective of this symposium was on mainly on the secondary aerosols formation and growth. So even though the NPF studies have been going on for last 15 years or so, even in the advanced countries, but still we have not quantified like what is the contribution of this kind of secondary aerosols to CCN and how it alters the cloud and precipitation microphysics. So that is still not very much quantified, especially in India it's not much. So as an outcome of this symposium, are we like planning some collaborative major campaign in any selective location wherein all groups can bring in all these facilities at one place and address that? So yeah, otherwise sporadically several groups are working independently here and there, but there is no so as a recommendation of this, we can put up a major proposal and so it can come up like, because there are complaints also. People are not coming with the big proposals. So small proposals are going from different institutions. So it could be a international collaboration proposal. We had good speakers today like Manish from PNNL and all. So can we plan something big in India? So that could be one recommendation from this.
Please.
If my comments are not really aligned with the aerosol, but I see there was a regional emission can constrain local air quality. I see that. So are we are we just talking about the PM 2.5 here, or just air quality means, or because there are emission inventories in India needs to be updated. It's we are really so I'm not sure if that's the scope of the.
Yeah.
Be modeling based, right? For measurement based would be difficult.
Yeah, that's
measurements. Okay, but then you have to have multiple data sites, not just one or two sites. Yeah, exactly. Yeah.
I mean, for emission inventory, you need to have the emission ratios, emission factors. So for that, you need measurement, right?
Yes.
So.
And definitely more than just PM 2.5.
Yeah.
First of all, thank you so much for the organizers for this wonderful session. And we all are talking about like the formation of aerosols and the hazards of these particles. So everyone knows these are not very much good for our health, and we should also go forward for the solution of removal of those particles from the air, as well as from indoor as well as from outdoor. So I think these would be like a better suggestion. Thank you.
Exactly.
Yeah, means one thing I felt in these 2 days not discussed more is about lab scale experiments. So when Dr. Pandithurai is suggesting bringing or putting proposals, yesterday Dr. Lubna showed the kind of experiment they are doing. Like they are showing 6 AMS club together in one place. So and as a modeler, I generally feel that my regional scale sophisticated model also doesn't have proper chemical equations. right? So those kind of experiments coupled with modeling studies can actually go from microclimate to regional and cover most of the questions we are trying to address.
One recommendation for measurement. I would suggest means now whenever we are taking the measurements, we should do size segregated chemical composition, because when we are doing PM10 or PM2.5, a few big particle will means take over the mass of all this one particle. If we have size segregated, then we know that okay, this size, that particular source is important. So size segregated chemical composition that is what we should consider.
Then mentioned, chamber experiments is something that you need a lot of resources. If I have to just look at sulfuric acid aerosol formation, I need SO2 analyzer, I need S2 sink, and so on. And that itself is too expensive. But chamber experiment basically meant to be control. You're doing something in control environment. Rather than replicating it, maybe we have a cloud chamber in Europe. Maybe we can come up with some kind of parameterization, and then we can incorporate into our regional models, what you have been doing, right? So probably that will be the best solution rather than creating chamber and then simulating what already people are doing. So again here, international collaboration or maybe integrating the information, which is available in the literature also. It's not that we have to have collaboration for some of the things.
I didn't quite catch you. Did you say that utilize the existing chambers and
yes.
not to build?
Yeah. Okay. Because it's a control environment, whether I do it or you do it, we are going to get the same result. Yeah, I know how much of SO2 I am putting in and OH. I know how much of S2 it's going to be there. Atmosphere is like cocktail. You don't have any control. But in chamber, you can control one particular VOC, isoprene, monoterpene, ozone, and look at what is happening. Yeah. So for that, we need in situ measurement. So we'll get some idea how much isoprene we have in the year. And in Europe, there might be difference. Chamber, exactly. We need to just know the rates and their quantification from the chamber study. That whether I do it or they do it, it's the same thing. Yeah. Yeah. Correct. That's true. I mean, once you have a measurements will tell you this much is there, that much is there, but you will not have any mechanistic understanding. You have to rely on models and probably some kind of experiments to know the physical mechanism that is, or governing processes that is happening in the atmosphere. But of course, you need measurement, and along with probably chamber studies, and basically you need everything in order to come up with a superior process level understanding. There is no shortcut, yeah, especially. Yes. 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 Yeah. That's what Dr. Panditu has suggested. So, yeah, we should do that. We should bring at one place and then do it, whether it's campaign-based or continuous. I think we should do it. That's a really great proposal. Logistically easy, yeah. Considering the resources, yes. Yes, let's hope that we'll have funding opportunities to cover logistic support, and that should
that should help, I think. You agree? Okay. All right. Any other suggestions?
Yes, more
recommendations?
comments.
Yeah. Yeah, Andy, over to you.
Please go ahead. Yeah.
The collaboration among, I think it's just following that comment, having that everybody together and doing the measurement, but to solve or to really understand the problem, we also need to bring other scientists like, epidemiologists. So we need to bring health experts. Same, I think agriculture is such a, important topic. So we definitely needs to collaborate with people from different fields. That's what I don't know. I don't mean to just really expand that, but yeah.
Let's take everything in, and like I said, that the organizers will go through it and come up with the suggestion paper then for everybody at
Thank
the
you.
moment. Any more comments? I have one very practical question for anybody to answer. How to ensure that the collaboration happens, that it's not only discussion now? Who will host the next NANO 24?
Yeah, I have a small query.
Please go ahead.
So, in policy perspective view, what are the regional and global impacts of aerosol-related forcing on ecosystem as well as air quality and public health, and how we can address these impacts in climate policy and how we can take decision making?
I will try to remember your comment now. What are the impacts of climate change or air pollution? What did you say? Can you repeat that maybe?
So, what are the regional and global impacts of aerosol-related forcing on ecosystem and air quality as well as public health, and how we can address these impacts in climate policy and how we can take decision?
Good. So does anybody have then answer to my question that how do we ensure that the collaboration happens that we have now been discussing? Because typically it happens so that, we go home now. But at the minimum, I think that this kind of regular meetings could be there.
And also at least if there are collaborations established at the university institute level like we have with recently, so that will facilitate more student and faculty exchange and those things.
So we already have an MOU from IIT Madras and Helsinki and Delhi. So this could be probably the one way to ensure that it happens.
Yeah.
like you when the time comes for the proposal.
You just introduce it now.
And even now many IITs are going actually beyond MOUs, and then they have started dual PhD programs. Like we have IIT Bombay has with Monash and others.
I'll share with the candidate the form.
So you have the answer?
I think I have already some ideas. Okay. Anything else from anybody? Or have we emptied the bank for now, after 2 long days? Okay, let's conclude. Thank you so much for a good brainstorming.
Thank you, everyone. Thank you, Auntie. Okay, now yes, of course. We have a poster presentation prize distribution now, which is supported by SGN controls. So I'll just run this in background while I'm doing my stuff. So we had total 18 posters. I mean, there were 18 submitted and 2, 3 withdrawn for genuine reasons. They had a UGC NET examination or something, so they had to withdraw. So total, I think there were 16 yesterday and today. We had a jury panel for evaluation of poster, and there were 2 rounds. Round 1, jury mainly looked at the scientific novelty, and in round 2, they were looking at the presentation skills and stuff like that. So out of 16, we shortlisted 5 best 5 posters, and out of that 3 presented here this morning. I've already shown you the list. So we have the results. So I'll now call from last, of course. So we have 2 consolation prizes that you already know, Pallavi Padwal and Oishi Chakravarti. So yeah, can we have Pallavi and Oishi? And may I request Professor Krishna to please present the awards to the awardees. Where is our photographer? Yeah, that is video. That is video. 1 second, Vaishi. Yeah. Can we? Yeah, we will have a photo. Oishi Chakravarti? Yes, all of them. She is our student, sir. She is now at IISc Bangalore. Yeah. And number 3 goes to M. Deva Prasad. Yeah. Sorry, I don't have that. PRL Ahmedabad. You're a student of Neeraj? Okay, now I get it. Oh, I did not know that. Thanks. Good. So he gets a memento plus certificate and a little cash prize. The second goes to Arun Nair from IIT Madras. And I guess if you have guessed who is the first. And of course, the first goes to Subrata Mukherjee from IITM Pune. So we have a special gift for him. That's a 3-channel diffusion dryer. I don't know if I have a video here.
He is from IIT?
IITM Pune.
ISR Pune. No,
IITM Pune, Indian Institute of Tropical Meteorology Pune. Yeah.
Quality monitoring station.
Yeah, yeah. So 3-channel, 3 parallel channels of maximum efficiency. This is a dryer which features 3 separate channels, each surrounded with silica gel beds, allowing to process more aerosol samples. And yeah, you can see the little animation and their analysis there. So the poster awards were supported by Edgen Controls. Okay, congratulations all the awardees, and congratulations to others also. You will get next time. So don't worry. Not here, somewhere else. Right, so with that, we are towards end of this session now. So I'll do the formal vote of thanks, unless if anyone wants to add anything before I do that. Okay, I guess assume no. Right, so on behalf of organizing committee, and of course my convener, co-convener, Dr. Rakesh Huda, I'm really pleased and honored to be standing here to convey my gratitude and regards to dignitaries, delegates, the participants present here, the faculty members, our university supporting staff, and other members who have helped by, directly or indirectly. So let me first and foremost, it gives me immense pleasure to extend my heartfelt thanks to our chief guest, Sri Vasneji, who for gracing the occasion and for spending one entire day with us. I would like to also thank our guest of honor, our beloved Vice Chancellor, Professor Bijay Rao, for accepting our invitation and addressing the gathering and making sure that he reaches for the inaugural session on time. Yeah, even he was out of country a day before. And of course, with his really motivational kind of words and his enthusiastic support to the university and to our center has always been very encouraging. I also thank our esteemed guest, Dr. Mikka Tironen. He is a Counselor of Science and Education in Embassy of Finland in New Delhi, for gracing the occasion with his presence. I'm thankful to the Dean, School of Physics, for being there and for unflinching support extended to our center. Of course, I take this moment to acknowledge and thank our head of the department, Professor K.S. Krishna, for his dedication and guidance that you have provided and for backing up us with, in our efforts with this symposium and even other activities at the center. I thank all delegates, particularly who have come all the way and joined, and of course, some of them joined virtually from US, UK, and Europe, giving your time and agreeing to share your knowledge with us. It was an honor for our center and university to have had such a prominent speakers delivering a lecture in their respective research fields. Particularly, I would like to thank each one of you for strictly following the allocated time for the talk and making my life much easier. You were the, I can't say you were, actually you are the heart of this symposium, right? And you will be always. So I said you because this is not the meeting which is going to end after this, as Auntie also pointed out. We are going to have more deliberations, probably white paper, and in future also collaborative projects and things like that. So yeah, thank you so much for all all the delegates, all the speakers. I also would like to thank and congratulate student participants for coming all the way to attend the symposium and present your ideas. And as jury told me, the posters were very competitive. They had a hard time. And we had almost 1 hour, 40 minutes. And I'm happy that they utilized the entire time evaluating your posters. And I don't hope, rather I'm sure that you have found this symposium fruitful, and definitely you have learned something and gained something from this symposium. I congratulate the students who have received the Best Poster Award, and I'm confident that it will motivate you in your future endeavors. I thank our sponsors, Institution of Eminence, University of Hyderabad, TSI Instrument India Private Limited, Indian Institute of Tropical Meteorology, Pune, Ministry of Earth Sciences, MG Analysis System, Pune, SGN Controls, TESCON, without whom this event would not have been possible. Particularly, I want to thank Institution of Eminence, director, who has been, considerate about the needs of our expenditure. So, yeah, thank you so much. A sincere appreciation to university and administration for providing all the support that we needed, different kinds of permission at the security, and even today we had some kind of a protest, but yeah, we had a great time last 2 days. I sincerely thank the Finnish Meteorological Institute, Finland, for being a co-partner in facilitating the global peer speakers of the subject, framing and supporting the host University of Hyderabad in organizing this particular symposium. And sincere thanks to my faculty colleagues and of course office staff. They are the support system, for their kind support and encouragement as always over the last 7 years. I'll be completing 7 years on 31st March. So with that, yeah, thank you so much. Last but never the least, I cannot overlook the tireless efforts of our technical and organizing committee. I'm so grateful for organizing committee members, Dr. Srijit, Dr. Stella, Dr. Charan, Matthew, Varaprasad, Vaishali, Duraimaran, Anibisha, am I missing anyone? Paul, who was not well, and I have asked him to, take rest, but he was just hanging around. So I'm really grateful to you guys for your dedication, the effort that you put over last 2 months, especially last 4 or 5 days. And also, of course, I'm so grateful for my co-convener and our organizing committee members, Professor Chakravarti and Dr. Devalina Mani Tiwari, for their support over last 1.5 or 2 months. Since the wheels began rolling 2 months ago, when the symposium was put into action, the technical committee members, have been working diligently, and I really appreciate and our research scholars. They are not just our support system in the scientific field, but also in some of the other technical fields also. So thank you so much, one and all. Thank you all once again, and for making this event a grand success. Thank you. Thank you so much. Yeah. Thank you. Yeah.